Oops. Okay, all right, so welcome back. Week 4 of GCOM 402 and Tuesday in Davis. Today, just before we get started too much with going into the shader tree, I just want to draw focus to the course page because I've already updated and uploaded all of our Week 4 content. It's under Creating Materials and Textures, and if we check it out, this is going to be, our conversation this week is going to be a continuation of where we kind of started last week. So on our cork board, we kind of left it very basic, very simple geometry. We focused more on the modeling aspect of the cork board. Well, today we're going to focus our entire conversation around the shader tree and really get a good sense and a really good understanding of how the Moto rendering engine processes all this stuff, if you will, to create an image. So it's all going to be about the shader tree today. At the conclusion of this week's conversation, your homework is going to produce your cork board, but it's going to have textures on it. So we're going to put images on the posters. We're going to put images on the board itself to make it look like cork. We're going to find ways that, or find some other cool processes to add the illusion of wood grain. So we're going to make our little cork board come to life. I love texturing. It's one of my favorite parts of the entire modeling process because ideally, or what ultimately happens, is that our objects truly come to life. Up until now, it's just kind of this gray shape, but the moment we start putting textures on it, the moment we start dialing in the materials, is the moment that this shape becomes something that's real. You know, before that, it's just a 3D model that only exists inside of Modo. These textures and material bring a certain amount of life to our objects, and I love it. It does require some mastery of some really interesting concepts. Shading our models in Modo is not difficult, but it is different from other 3D modeling applications. So we're going to be talking about how the Moto rendering system works inside the shader tree. We'll get a good solid understanding of the architecture of the shader tree and understand how it processes all of this information within inside this one special environment. Okay? I think once you start to understand the component parts, the interface of the shader tree and rendering environment is going to make a lot more sense. I've been intentionally kind of kicking the can, if you will, on our shader tree conversation. We've talked a little bit, and I mean a little bit, about materials. Today, we're going to really jump in and get into some detail. Okay? So this week's homework assignment is going to be the conclusion of our cork board. As always, if you want a short little time-lapse video that illustrates the process that I go through to texture my cork board, is there. We'll come back to that here in a minute. Okay, for our lab this week, we have another fun little exercise. I'm giving you this scene file of this really groovy lighthouse. And your job during the lab today is to apply materials and textures to the entirety of this little lighthouse. You're not going to be doing any modeling. You're not really going to be focusing on the construction of the lighthouse, just on applying the materials. When you're working with materials, we have to develop a certain degree of muscle memory because there is kind of a system that we need to work within. This lab exercise is going to get us into that system rather quickly. In addition to talking and kind of reinforcing the system of applying materials, it's also going to give us an opportunity to look at the process of applying material presets. Moto comes with some really amazing presets that helps us achieve that photorealism pretty quickly. They're beautifully designed presets by a professional design firm down in San Francisco. So it's not like if you're used to using presets in other applications, they're horrible because they were designed by like engineers, okay? These presets were designed by artists, so they work beautifully, and we'll get back to that towards the end of our conversation in class today. If you look at the Resources tab, here's the model file that I would like you to use for this week's lab assignment. It's under the Important Documents section. And to supplement our conversation today, I've created a whole series of videos that really dive in and address most of the big concepts that we're going to be talking about today. Specifically, if you really need a solid refresher on how the entire shader tree works, I can't recommend enough that you use and take a look at this video right there, okay? Actually, I'd say jump up and down about these top 2 ones, okay? These top 2 ones are really, really important. So don't forget about the videos. They're short. I know a lot of you guys don't like the idea of watching a 3-hour lecture to get, a 10-minute little chunk out of that, okay? That's why I have these videos here, okay? These live streams are an excellent resource for those that can't attend class, and if you're the type of person that kind of keeps a cognitive connection between what I say in class and what you see in the video and the content. It's also an invaluable resource, but I'll be the first one to admit it's 3 hours, or it can be anywhere between 2 and 3 hours. You know, it's hard to find content within that huge video. So these smaller ones will help. Okay, so use them. Use them. They're a fantastic resource to help you navigate the treacherous waters of the shader tree. Okay? All right, questions on what we're going to be talking about this week? Sweet, let's jump in. Let's jump over into Modo and begin our conversation on how the shader tree works. Now, I'm opening up Modo 601, but if you were to go down to the lab at main campus, you'll find that we're using Modo 701. It's rather unfortunate that our IT support staff has not upgraded this lab to 701. This is the 3rd week of no response from IT, and I'm getting rather frustrated with them. So I think I'm physically going to go knock on a door tomorrow when I'm on main campus and really kind of motivate them to get this lab up to par. I bring this up because the environment that you're going to be working with inside the shader tree and the render tab in 701 is a little bit different. Okay? The way they've laid out the interface is different from what we're going to be learning and experiencing here in 601. Now, luckily, it's not different to the point that you're going to be completely confused. All the same windows are there. They're just put in slightly different places. So be aware of that. The shader tree is there. The properties tab is there. It's just in there are small differences between the two environments. Okay, maybe I'll show you 701 towards the end of class just so you guys can get a nice visual example of what I'm talking about. Yeah?
The computer lost the license again.
The computer lost the license again. Is anyone else running into that problem? Okay, Jessica, right? Would you mind jumping ship and come over to one of these machines? I know that's not ideal, but in order for us to reinstall the license, I have to go get a supervisor, and he has to plug in it's just a process, the process that you guys were witness to 3 weeks ago, okay? I apologize. This machine right here might work, Jesse, so you might not have to go very far. Okay. Yeah, give it a try. See what happens. All right. I want to start off today just by creating a very, very simple scene. I think the process of understanding how materials and textures inside of Modo is most easily illustrated with a very simple scene. So I want to go back and kind of leverage the power of some of those unit primitives that we were making before. So I want to construct my entire scene with just some basic shapes. Basic simple shapes. Some cubes, maybe a cylinder or two. We'll definitely include a sphere because I like spheres. It's okay. So I'm going to go up to my Basics tab, and I'm going to hold down the Shift key to add a cube into the mix. Okay. And here we go. Then I'm going to hold down, let's put a cylinder in there, and I'm going to go into my polygonal selection set, double click on my cylinder, and just move it out of the way. I think I'm going to move it maybe somewhere, I don't know, right around there. That looks good. How about we add in a sphere here? Now my sphere, when it was generated, was placed at the exact same location within my 3D scene as my cube. So I'm just going to hide it real fast by hitting the H key, which gives me access to my little sphere. And I want to move it over here. Hitting the U key will unhide geometry within our three-dimensional scene, and that's starting to look pretty good. Here, I'll tell you what, I'm just going to do that. I'm going to just kind of tuck it up next to that cylinder. And then last but certainly not least, let's add a cone. I've always been a big fan of cones. There we go. And I'm simply just going to move this one kind of in front like that. All right. Now I'm going to show you an old school trick here. I want to have a ground plane. Okay. I want it to look as though all four of those simple primitive shapes are just chilling on some sort of ground. What basic shape is a ground plane? It's a plane, so what shape is it? A cube, right? If you want to create a simple ground plane quickly, without a lot of fuss and fuss, use the cube tool. We're not going to be using the primitives, the unit primitives, so we're not going to hold down Control or Shift, but I am simply just going to left click on it and then just draw out, oops, let's try that again there, Pat. Here we go, draw out just a very simple shape, and that's all I'm after. Here we go. All right, I think I might just take my cone here. Oh shoot, I'll just scale it down. Make it smaller. Move it in like that. That works. Shoot, I'll even grab my ground plane and move it down so it looks as though my cube and my sphere and my cylinder are all just sitting hanging out. Oops. On my ground plane. Let's move that down, and I'll just kind of tuck it in. There we go. Okay. Voila. I love it. Looking very, very nice. Now that we have our simple scene constructed, I want to jump over to the render tab. And as a refresher, you can find the render tab at the top of your screen. We've been chilling and hanging out in the modeling tab. Okay. Well, now we're going to go all the way down to the end of this row and hang out in the render tab. Now, this render tab is a special environment for us. And as we saw a couple weeks ago, the render tab gives us access to some viewports that are going to give us a real-time preview of what our final render is going to look like. And I've changed my environment around. Let me just kind of restore it to what it may look like on yours. Okay? So help me out. From our conversation over the last couple weeks, give me a small little tour and give me a small, simple little explanation of the roles of each one of these windows. What are they going to do? Let's start with the upper left-hand corner, the one that looks all gray. What's that one going to do? Mika? Yeah, this is our preview window, okay? The preview window is amazing. If you're coming from another application, you're going to love working inside the preview window. I think the preview window in Moto is the reason to buy Moto. It is the bee's knees. I love it, okay? So this is going to be the preview window up here. On the surface, the preview window is going to give us a real-time preview of what the render is going to look like. So this is a window into our final render. Now, is it the final render? No, okay? So just because you see an image up in here doesn't mean you've necessarily rendered your scene. It's just a preview, okay? It's a teaser of what the render is going to look like. And it's a one-to-one preview, okay? So what you see in that window is what you're going to get, okay? So we got preview. What's this one over here? It's the camera view. And I think a better way of understanding what the role of that window is this is kind of like an OpenGL representation of the preview. It is the camera view, and we know that by looking in the upper left-hand corner of that viewport. You can see that the viewport label does say camera, okay? And what we're talking about is that guy right there, okay? It says camera. It's an OpenGL representation of the preview window. So this is going to be what the render is going to look like. This is how our OpenGL scene sees our environment. And then this down here is just kind of a regular perspective viewport. I think of this perspective viewport kind of as a work area, okay? So for me, this is where I'm going to go in and really kind of toggle the placement of all of my lights, kind of dial my cameras, and get it gives us a really nice sense of the placement of all of our objects within our three-dimensional scene, okay? All right. Before we go too much further, I want to talk about the awesomeness of the preview window, because there's a couple things in here that really make it an important addition to our rendering pipeline. Now, the preview window, as I mentioned, it's a real-time preview of what the final render is going to look like. And as we have already talked about in this class, when we're rendering something, really what we're doing in many ways is that we're taking a picture of our three-dimensional scene. Well, in order to take a picture, we have to have a camera, right? And if you look closely, that's what this guy is over here. We actually have digital cameras inside of our three-dimensional scene that's going to help generate our image. And the properties of those three-dimensional cameras are going to behave almost identically to real-world cameras. So if you're a photographer, this is going to be an easy environment for you to work with, because we get the same ideas of shutter speed and aperture and film backs and different lens types. We can apply all of these real-world camera settings to our digital ones here in Modo. So it's a really powerful system, okay? Where our camera is placed within inside of our three-dimensional scene is absolutely going to determine what we get up here inside of preview. So this guy is ultimately going to drive the composition of all of this stuff up in here. Okay? We have a couple different ways that we can go in and navigate and control the composition of our cameras. Give me one. Maybe I want to see, if you look very carefully at my preview window up there, what we're not seeing is like the sphere and the cone and all that other stuff, right? I physically need to change the location of my camera within our three-dimensional scene to get all the stuff that I want to render. How do I change my camera composition? Yeah, hit me.
In the top right viewport, you can change using the alt and then mouse.
Yeah, absolutely. And specifically what he's talking about is that we can use the exact same viewport navigation controls that we've been using up until now to influence the position of our camera within our scene. Let me show you what I'm talking about. I'm just going to simply check this out. If you put your cursor like kind of right on the border of all these different windows, your cursor changes. And let me zoom in so you guys can see what I'm talking about. Folks in the back are probably going, what? It's crazy. See, my cursor changes. And if I put it right there in the center, see how it goes to that left, right, up, and down arrow? Well, now I can grab that part of the interface and kind of change the size of all of my windows. And I like to do this just for you guys in this class because I understand that the projector that we're working on is quite small. Okay, so now that I've made my preview window just a little bit bigger, check it out. I'm going to hold down my Option key, or for you guys on a PC, the Alt key, and I'm going to use the left mouse button and drag around in my scene. Now, if we were in a standard OpenGL viewport, we would orbit. Okay, well, in the preview window, we're going to get the exact same orbit function, but what we are fundamentally changing is the location of our camera within our scene. Okay? So all of our traditional viewport navigation controls that we've been used to working with up until now can be applied to our preview window to change the composition of our camera, to change its location within the scene. To further illustrate this, check this out. I'm going to go down into my perspective viewport. Okay, check it out. So there's my camera right there. Okay, if you look carefully, shoom, there it is. Okay. So now, when I watch my camera, when I orbit inside of my preview window, as soon as I mouse up, you can see that its physical location within inside of my three-dimensional scene is changing. This is awesome. Why? Why is this special? What does this ultimately allow us to do? We can see everything, absolutely. What else? Why else? Why else is this something that's really special and really important to understand and remember? It makes it an efficient system, okay? This is a speed thing. We no longer have to go select our camera and move it with those really kind of ancient, archaic move tools, okay? Because moving things in a straight line can be problematic, okay? I love that I can just go into that preview window, use the same viewport navigation controls that I use in every other window, and compose my shot. Very quickly, I can get to my final render, okay? Just by using Option left drag to orbit, Option control to zoom in and zoom out, Option shift to pan left and right, up and down, okay? It just gives us speed. Just gives us speed. So now I can go in and compose my shot and get a really good understanding of what the final render is going to look like in about a heartbeat. Okay. Now, if you want some control, if you really want to get that fine level of granularity as to where you're placing your camera, you can. You still can go in and select your camera in the item list. Okay. Cameras are classified as an item type. Last week we spent a lot of time focusing on the role of items. Cameras are one of those items inside of our scene. So if I was to go into my item selection set, check it out. I can grab my camera just by left-clicking and dragging on, or by left-clicking on it, and then activating the move tool will allow me to move that camera anywhere in the scene. Okay, and you can see its composition and what that camera is going to render up inside the preview window. Okay, so you have two different ways of doing the exact same thing. You're going to very rarely see me going down and selecting the camera in the OpenGL viewport. I traditionally use the standard viewport navigation controls to get me where I need to go upstairs in the preview window. Because it's just that powerful and it's just that good. Okay, let's talk about our scene for a second. Okay, now if you're following along and if you've constructed a very simple scene like I have, I would love to encourage you to let me just do that so it's real easy to see what's going on. Okay, I would love to encourage you to activate global illumination within your scene. Okay, we talked about this a while ago, and for the moment, I just want you to turn it on. We're going to talk about its role inside the rendering pipeline towards the end of our conversation, so we'll get back to it. but just turn it on. Ultimately, what the global illumination system is going to do is start to generate all of the color information and from the lights in the scene in the shadow areas. If you look carefully here, you can see that 100% of the objects that are in shadow are getting kind of the same color. We don't get any indication on the ground plane here of those, we don't get any indication of the objects that are along the ground plane because they're, I'm sorry, see. What? Yeah, so great question. Great question. So if you want to enable your global illumination, it's really simple, super easy to do. However, the first thing that we got to do, let me zoom in on my shader tree. Okay. The first thing that we got to do is ensure that we're in this shader tree tab. And at the top of the shader tree, we have this render property, this render item. It's the one with the big purple sphere next to it. As always, whenever we select an item within any palette or any form inside of Modo, its properties are going to become available to us in the Properties tab immediately below that window. So I'm in the Properties tab, just navigated vertically down within our scene, and you can see that like our Tool tab, it's broken up into a whole series of vertical tabs. Now, if you're following along, just go to Global Illumination. That one right there, and all I would like you to do is hit the Enable button. Just turn it on, okay? Hit Enable, and look what happened to my scene, okay?
Can you go over that one more time, please?
Yeah, absolutely. So I went into the render item, okay, which is the one with the purple sphere, and I went down into my Properties tab, and specifically, I went into the vertical tab on the right-hand side of my Properties window into Global Illumination. And all I've done here is just enabled it, and just turned it on by clicking on the box. Okay. I call global illumination inside of Modo instant production value. Okay. It's a really advanced system. You are very lucky to be working with probably one of the best global illumination rendering systems on the planet. It's wicked fast and incredibly powerful. Okay. It's so powerful and so fast that in 701 they've enabled global illumination on by default, because the speed of our graphics processors and our computers have gotten to a point where you really shouldn't be rendering without global illumination on. I mean, there's no reason not to do it anymore. In other applications, it's quite a process to set this entire system up, and the results, and good results, are very difficult to come by. In Modo, we hit one button, things are looking badass, you know, almost immediately. Okay. Okay. So now that we got our simple little scene, let's talk about how the shader tree is going to work. Now, let me zoom in, and we'll just take a smaller, a little sneak peek here at what we're working with. All right. So welcome to the shader tree. This is going to be our home away from home. This is going to be the environment that we are going to be creating all of our materials and all of our textures within. So this is kind of like our item list, but just for materials and textures, okay? We're going to talk a lot about the role of materials and textures, but basically, from a 10,000-yard description, our materials are going to establish the surface characteristics of our shapes, okay? So they're going to determine if the shape is shiny or plastic, or if it looks like metal or chalk. It's ultimately going to tell the computer what type of surface our objects have. As 3D modelers, we need to start looking at our environment a little bit more critically. We need to look at shapes, but we also need to understand how light is going to interact with those shapes in our scene. Just looking around this room, I can see a whole suite of different surface characteristics on all the objects, including you wonderful people. Okay, you know, how the light is bouncing off of your hair, off of your skin, is different from how the light is interacting with the hard metallic surfaces on that light on that table over there. Okay, or on the clocks, or the overhead lights, or this whiteboard up at the front of the classroom. We need to start seeing our world through the lens, if you will, of how light interacts with surfaces. And materials allow us to change those characteristics pretty quickly. The shader tree is a really powerful environment that allows us to create some pretty complex systems of shading networks. Okay? If there's one source of inspiration for how the shader tree works, I would say that the shader tree behaves identically to Photoshop. Okay? In many ways, the shader tree kind of has been inspired by the layer system that we're used to working over in Photoshop, right? Now, how many guys have some experience working inside of Photoshop? I do. I love Photoshop. Photoshop is probably the most powerful application in the image editing class, okay? I mean, it really is amazing. It's got a long history. It's been around for like 25 years. It's one of the original, well, I think it is the original digital imaging editing application. And it's fun. It's fantastic. If you don't know Photoshop, you have to know Photoshop. Okay, Photoshop is the common denominator in all digital art. Okay, so I don't care if you're doing websites, graphic design, 3D textures. Everything is rolled through Photoshop at one point or another. So you need to have that little tool in your toolbox. Okay, it really is invaluable. I'm going to burst your bubble. No one uses GIMP. Okay, I think GIMP is a great application. I think for its price, it does some really amazing things. And if you're not familiar with the price of GIMP, it's free. Okay, it's an open source image editing application. But the cold, honest truth is, out there in the professional world, no one uses GIMP. Okay, so don't waste your time working on an application that no one, and I mean no one, is working with out there in the real world. Okay, learn Photoshop. GCOM 330 within the Sacramento City Graphic Communications Department is going to facilitate your exposure to Photoshop. Okay. Now, Photoshop works on a very cool process, okay, of layers, right? And if you think about it, in Photoshop, whatever is up here at the top, okay, all of this stuff up here is going to influence all of the layers, and specifically the visibility of all the layers that are below. Okay. Now, we kind of have the exact same system here, except it's reversed. Okay? Check this out. The shader tree is evaluating all of its different sections and components from the bottom going up. Now, let's talk about why it's doing it from the bottom going up. If you look specifically, now we're going to ignore this FX stuff for the time being. Okay? Just ignore that. That's something that you'll explore a little bit when you get to GCOM 410. But for today, just ignore that it's there. Okay? Now, if you look at what's at the bottom of the list, you'll start to get a better understanding of why it evaluates the camera first and works its way up. So we go this way. The flow of information is going from the bottom of the shader tree up to the top of the shader tree. Okay? Now, at the bottom of the shader tree, you're always going to find your camera. Okay? Now, what does your camera officially do with inside of our scene? What's its role? To view the render. Now, what are we going to see inside, or what does the camera see?
Whatever it's pointed at.
Whatever it's pointed out. So it's really ultimately determining which areas of our three-dimensional scene are going to be drawn, right? Whatever the camera sees, that's what's going to be evaluated. So if I'm looking over here, right, at this side of the scene, if this classroom is a three-dimensional scene and I'm taking a picture of you guys in front of me, right, is the rendering engine going to be evaluating the stuff behind me? No, okay? What you see, or what the camera sees, is really ultimately what's going to be evaluated by the rendering engine and ultimately drawn on the scene, or in the render, in the image, okay? So it makes sense that the first thing that's evaluated is the camera. So the computer can very quickly start to understand how much information, how many polygons it's going to render, their orientation and placement within the scene, all that fun stuff, okay? So camera is number one. Number two is this guy, okay? Specifically, our lights. These are called direct illuminators. These direct illuminators, or AKA lights, okay, provide illumination within the scene. Now, these light types, we're going to have a big conversation about the many different types of lights that we can create inside of Modo a little bit later on this semester. But ultimately, these light types, these light items, are going to cast little light rays, little photons out inside of our three-dimensional scene, and very similarly to the way actual lights work in our universe, okay? The Modo rendering engine is so cool, or one of the reasons it's so cool, is that it has at its core what's called a physically based lighting engine, okay? So it's taking those physical properties from real-world lights and the physical theories that drive their interactions with objects within the scene, and it tries its damnedest to recreate that, So our directional light, you'll hear me talk about this in a couple of weeks, our directional light really kind of resembles the sun in many ways. A directional light is kind of this endless light source whose orientation, so its rotation, determines how the shadows in our scene are ultimately going to be drawn. The rendering engine needs to understand the location of this light so that it can start to understand and figure out the intensity of these photons as they hit the surface of our guys, or the surface of our objects within the scene. As we saw from our example, it also is going to help determine the shadows. That's something that the computer is going to need to understand. Where are the shadows in the scene? How are those shadows going to be drawn? What other objects are going to cast shadows and receive shadows? So that's an important characteristic for the rendering engine to understand and work with as well. Keep going up the list now. What we got next, number 3 on the list, is an environment. Okay? We're going to come back and talk about the role of our environment, but basically what our environment allows us to do is to create the illusion that our object is actually inside of a bubble. Okay? Whenever I think about an environment, I think of like a beach ball. Okay? At home right now, my son has a beach ball that he plays with, and so my mind's kind of going to a beach ball right now. All right. So imagine our 3-dimensional scene like a beach ball. Okay. But we're not looking at this beach ball from the outside. Okay. Our 3-dimensional scene exists on the inside of this beach ball, and we're looking from the center out. So are we seeing the inside wall or the outside wall of our beach ball? The inside wall. This environment is basically that inside wall of our little beach ball. And we can place images back there and colors to make it look as though our scene is in a very specific location or is being influenced by very specific colors in our environment, right? Because here on planet Earth, everything is encapsulated by, we're kind of the same thing, right? We're on the inside of a gigantic blue beach ball, right? If we're standing outside, the clouds, the haze, the atmospherics in the ozone is going to influence how that object looks, right? Well, we have to replicate that. Okay, kind of going back to being incredibly observant. We have to replicate how the interior of that beach ball looks, so that our renders are drawn in a way that looks real. Okay. You'll see me messing around with the environment a little bit later, so we'll come back to that. All right. The next section is, in actuality, the next section that the computer evaluates in actuality is that render item. Okay? And so it goes from camera to directional light to the environment and then to the render item. Now this render item is broken up into a whole series of subcomponents, and these are the most important things that we're going to be working with today, are all these subcomponents of the render item. Okay, so if we were to click on that dark arrow and expand the render item and look at all of their subcomponents, you're going to find once again that Modo is going to begin to draw or be influenced by the objects that are down here at the bottom. So this guy, the base material, is the first component that the render engine is going to evaluate. What direction is it going to go from there? What's the next thing it's going to evaluate? The base shader. Okay. And then it's going to go to the final color output, the alpha output, and then it's done. Okay? The base material is responsible for establishing the surface characteristics of every single polygon within the scene itself. Materials, and let's just take a look at some of the properties of a material. We're going to come back and talk about these in detail in a minute. But these are all the different properties that we can change and leverage to try to create a very specific surface characteristics. So for example, if I wanted to make my guy, maybe I want my sphere to be metallic. Well, I'd turn up the reflection amount. I'd decrease the roughness. Okay, we have to change a lot of these parameters to make our objects look like their real-world counterparts. Materials do that for us. The one that's probably the most influential on the surface and for beginners is this diffuse color, as the diffuse color value is what ultimately changes the surface color of our shape. Okay? We'll come back to that in a minute. So materials are all about establishing how the light is going to interact with that surface. Okay? The next thing up on that list is the base shader. The base shader plays another critical role, or all shaders play a critical role. But ultimately, the base shader is going to control the visibility of the items that are below it, okay? And other things. I'm selling the role of the shader a little bit short, but I think just for today, the base shader is going to control visibility, okay? Anything that's below the base shader is going to be influenced by that guy, okay? We'll come back to that in a minute. So shaders, visibility, and we can also adjust the qualities of the objects that are applied to those base shaders. And then we get to these two guys. Now these two guys are actually the same type of render item, okay? But their results are going to be a little bit different. If you look very, very carefully here, they have like the cutest icon known to man. What do the little icons look like? Yeah, I love the little Mona Lisa guys. I think it's just really cute that the way they've, just the Mona Lisa is the icon for a render item, okay, or a render output, excuse me. The top two ones, so the objects that have the little Mona Lisa icon next to them, are classified as render outputs, which is why each one of those ends with the word output. These are images, okay? This is physically what is going to be drawn. So when I hit the render button, I'm not drawing one image, I'm actually drawing two separate images, okay? Each one of these images is going to be generated based on the effect that render output is producing, okay? The final color output effect is going to be kind of what exactly you see in the preview window, okay? So what you see in the preview window is going to be placed in the final color render output. The alpha output allows us to save transparency channels for certain specific elements within our scene. We'll come back to that render output much later on this semester, okay? Being able to render our objects with a transparency channel and alpha channel allows us to do some really cool layering, some compositing work in Photoshop or After Effects or any number of applications. And it's an incredibly powerful addition to our workflow here in Modo. The takeaway for render outputs, these guys in here, is that these guys are the ones that are truly responsible for drawing the image. If you don't have a render output in your scene, the render engine isn't going to draw anything. Everything is kind of fed into that render output, and its sole responsibility is just to make a picture, okay? So as you can see, all of the different components and items inside of our shader tree are being stacked and built upon each other so that everything kind of flows from the bottom to the top and ultimately into these render outputs, okay? That's how the basic function of the shader tree works. Pretty cool, huh? Pretty cool. Any questions on what we've talked about so far? Everyone good? Let's get our hands dirty a little bit, okay? Let's start getting into it and understand the process of applying different material groups and using the power of the shader tree to make something that's a little bit more compelling. Okay. Now I want you to think back a couple weeks ago when we were working on our coffee cup. We applied some very simple materials to our coffee cup to make like the cardboard sleeve look like a nice lovely shade of brown, and the lid on many of your coffee cups turned out black. What did you do to get that result?
We turned the material black. We turned the material black.
We turned the material black. But how did you turn the material black? What was the first thing that you did?
Press M.
Press M. Okay, the M key plays a critically important role inside of our rendering operation. Let's just take a look at it real quick. Okay, let's localize the example. Maybe what I want to have here. I want to have my cube turn red. That's the goal. I want to have a red cube. Okay, the M key is going to allow us to do that. But before we hit the M key, let's talk about the role of the base material, because I can't walk away from that base material. Because the M key works in conjunction with this important material called the base material. Okay? The base material is responsible for shading everything in the scene, and I mean everything. Okay? Everything. The moment you create a polygon, it is automatically assigned to the base material. You can't change this, so don't try to, okay? Everything gets assigned to the base material. It's a powerful component inside of our shading system because it allows us to affect our entire scene globally, Let me show you what I'm talking about. I got my base material selected, so within its properties section down here, if I change any of these parameters, it's going to apply and affect everything within our scene. Okay? Let's just use the most simple illustration of that as I can, and we're just going to change the diffuse color, which is just kind of like the surface color. Okay? So if I change my diffuse color to red, what would you imagine is going to happen? Knowing that the base material affects everything in the scene, what's going to happen when I change its surface color to red? Everything's going to turn red. Boink. And there it is. Everything turns red. Okay? The base material is going to influence all polygons. All polygons. Okay? Well, what if I want to have my cube be green now? I don't want it to be red. Maybe I want everything to be red except the cube. Yeah, thus enter the role of that M key. The M key, if you're coming from a Photoshop background, kind of acts like a mask, okay? We're extracting those polygons from being influenced by the base material, and we're assigning them their own material, their own custom material, whose parameters are not going to be influenced at all by the base material. Let's do that. How did we assign the coffee cup to its own material? What did we have to do first?
Select it.
We got to select it. What type of component are we required to select? Polygons, okay? This is an action that requires a polygonal selection. Another reason, and this is another reason why having an OpenGL viewport down in the bottom part of the render interface, is really useful, because now I can go into my polygonal selection set, double click on my cube, and hit the M key. Question?
I'm not getting it. It's not selecting.
It's not. Make sure you're in the polygonal selection set, and make sure that you're on the item that contains all of those polygons. Often, whenever you're working inside of complex scenes, you can accidentally select the wrong item. Okay? So I'm on my cube item, which actually has all the polygonal information for all of the geometry in my scene. So just make sure you're on that item in the item list before you hit the M key. Okay? All right, so let me grab my cube. I selected it. I just double-clicked on it to select all the selected polygons on that cube, and now I can hit the M key. Some of you last week got a little confused as to why everything in your scene was, or everything was going to black, okay, or everything was going to a different color. We have to change the name of this material. If we leave it at default, it's going to be assigned to the base material, okay. And if the guys at Luxology are listening to my live stream, please change this to say base material. It'd be a whole lot easier to understand what's going on here, okay? Default, okay, is the base material. I don't want those polygons on my cube to be assigned to the base material, right? I want them to have their own material, their own custom material, so I can make it green. So I'm going to change the name of my new material. And let's just call it cube. We'll call it green. There we go. And clicking in the color section, we'll bring up my OS color picker. And I'll just choose this nice color green and then hit OK. You can already see my scene update, and this is what we have. Okay. So the base material is responsible for shading everything except the cube at the moment. Okay. Let's look at the interface, because some new things have popped up in our shader tree that are influencing how our rendering engine is drawing the scene. Let's check it out. Whoops, a little too close. All right. So here's our base material. It's responsible for driving everything in our scene, but now we've added a new player into the mix. And if you look at its icon, it's this guy. Okay, and it's got the same green checkered sphere, but it's got this red dot next to it as well. In my mind, what this is a folder, okay? If you're used to working over in Photoshop, you're probably used to constructing your layers palette with a whole series of folders. It's a great way to stay organized, okay? And then any transform that we do to that folder is only going to be applied to the contents of that folder, right? Well, we're kind of doing the exact same thing with this little guy. In actuality, it's not called a folder. It's called a material group. And the contents of that material group are going to influence just the polygons that we assigned to it. Okay? So when we selected those polygons and hit the M key, we created a custom folder, and then we assigned those polygons to that folder. Okay? Kind of make sense? Okay. Some other important things to look at on this icon is in gray text here. It says material. Okay, another strong kind of visual reinforcer that this thing is a material group. Okay, so let's expand the material group by hitting that little dark arrow and look at its contents. Because whenever we hit the M key and create a new material group, it generates its own material. Okay, so now we have two materials in the mix here. We have the base material, which is doing what? What's the role of the base material? What's the base material going to do?
It's the default for all objects.
I love it. It's the default for all objects. So everything in our entire universe is going to be assigned to the base material. Okay? Now I've created a new material group called green. What has been applied to that material group?
Green color. The green.
Polygonally, what's been applied? The cube, right? The cube. Those were the polygons that have been assigned to that group, okay? Only those polygons are going to be influenced by that group, okay? By the green material, okay? So check it out. All the materials act and behave the same, so there is no magic between them. They're identical in function. So if I was to click on my green material as I have here, the properties down below are identical to the properties that we're used to working with here inside of our base material. Okay? Okay, let's make some more material groups and let's completely kind of shade our scene to be the way we want it to be. Okay, so I want to have my cylinder in my scene be yellow. So what do I have to do to ensure that those objects, those polygons, turn yellow?
Select everything.
I like it. Darren's got it. Well, we're going to select everything?
Just the cone.
Just the cylinder, right? Yeah, Darren's got it. We're going to select the cylinder. Now, what type of selection set do I need to be in order for this to happen? Polygons. Don't be in item mode, okay? That's going to do something different. We'll talk about that in the upcoming weeks. I want you, for just today, our baby step into the world of shading, I want you to be in polygon mode so we can make a polygonal selection. So I'm already in polygon mode, okay? And I'm simply going to double click on my cylinder to select all the contiguous polygons on that shape and then hit which key? The M key. And I think I'm just going to name this material yellow because I want my cylinder to be yellow, okay? Let's check it out. Let's make it yellow. Yellow. And of course, the color is going to be blue. No, I'm joking. The color is going to be yellow. And there it is. Now we have a green cube and a yellow cylinder. Okay? Let's do it one more time. Let's make our sphere blue. Okay? So in my polygonal selection set, I'm going to double click my sphere, hit the M key, assign a new material, and choose its color to be blue. Or in our case, blueberry. There we go. Yes, sir?
Can you be in the items tab while you're working on these to make sure you're on the right?
Absolutely. Yeah, absolutely. The keyboard shortcut is a global keyboard shortcut. And you don't even have to be in the render tab to assign materials. You can be in the modeling tab or the paint tab. It's a global keyboard shortcut. I like being in the shader tree because I'm a visual guy. I like to see those material groups being created when I hit the M key, but you're going to come at it differently for sure. Okay, so now things are starting to look pretty good. Let's make one more. How about we make another material for my little cone down here? And I think I want to make my cone magenta. There we go. Ta-da! Pretty cool. Very simple scene. Each shape with its own color inside of our scene. Okay. one of the cool things about working inside the shader tree system is that nothing is set in stone. It's very easy for us to go back in and continue to add or make changes to the already established materials. Like for example, maybe I don't want my ground plane to be red. Maybe I want it to be white or maybe gray. Okay, so let's make a change to that real quick. Now, what is responsible for shading the ground? The base material. So I'll go down here. Here's the diffuse color value that's turning everything red. So if I change it to white, yay, pretty cool. Okay, so everything is live. Everything is accessible to us. Anything that any change that we make will immediately be seen over there in the preview window. Makes it very quick for us to go in, apply materials, apply textures, and go through our iterations as fast as we can. Being able to see almost in real time what the render is going to look like is actually special. You guys have it so good. Let me tell you. I remember when I first started working with Maya, just being able to understand how the computer was going to draw your scene could take, just getting a preview of your scene took, a full-blown render. Okay, so you didn't get a preview window. You had to do a full render of your scene to see what it looked like. Okay. This preview window is amazing. The process of applying these materials can be extended a little bit more, okay? Because ultimately what we're doing here is that we are assigning polygons to a material group, okay? So with that said, do you think I can mix and match materials on one polygon? On one polygon? No, okay? You can only assign one material group to a single polygon, okay? So one polygon cannot have two materials applied to it, okay? However, can I mix and match materials on a given object? Like for example, let's take my sphere. What if I wanted every other row on my sphere to be a different color? Can I do that? Absolutely, absolutely. Let me show you what I'm talking about. I'm going to go into my sphere. And here's a great little selection tip for you, okay? I'm going to select just a couple polygons along the top row of my sphere. And if I hit the L key, L for loop, it's going to make a loop selection that goes all the way around my object, okay? A real fast way to get a selection, okay? And I'm going to do this for a couple of them. You can do this simultaneously. There we go. So with those guys selected, let's make a new material.
Can you go over that shortcut again?
Yeah, it's just the L key. You have to make sure that 2 or more polygons along that row are selected, and then hitting the L key will select the rest of the polygons on that row.
And then if you want to select multiple, you shift.
Holding down shift, absolutely. See, I've just selected multiple polygons across many rows, then hitting the L key will automatically select the rest of those rows for me. Okay? All right, so now what do I do? Maybe I want to have all the selected polygons be red. What do I got to do? M. Everything begins and ends with the M key. So let's call it red. There we go. Hit OK. You can see what we have. Okay. At this stage, what we're doing is that we are assigning polygons to a single material group. Okay, just polygons. Let's do the exact same thing. Let's do the exact same thing for, I don't know, parts of my cone. Maybe I want, I don't know. Maybe I want the top half of my cone. Maybe I want the top half of my cone. Let's hit the L key. Or a couple rows of my cone. Come on, fingers. Work with me here. Maybe I want a couple of these rows in here to be, maybe I want a couple of these rows to be yellow. Maybe I want to recycle a material that's already being created or that already has been created within the scene. Is this allowed? Can we do this? Yeah, absolutely. We absolutely can recycle materials that are already existing within our scene. So we don't have to create new materials for every object. We can reuse the ones that are already there. I'm going to reuse the material group that's responsible for shading our cylinder yellow. Okay, in this case, I believe it's called yellow. So let's do that real fast. I got my selection already going. If I was to hit the M key, check it out. Here's our polygon set material option box that pops over our screen. Now, up until now, we've been adding a new name in this dialog box and then hitting the color. However, if you look carefully, that first line has a big selection arrow. Okay? If you were to click on that selection arrow, it's going to give you a drop-down list of all of the materials that have already been created and applied to our scene.
If you're working with like thousands of materials, can you type in the name of one material? Or what
Yeah, as long as you know the name of it and as long as it's exact to an existing material, yeah, it should work.
they won't duplicate the same material on separate?
It shouldn't. It shouldn't. I try really hard not to have 1,000 materials in my scene, but in theory, it should work. It should work. Yeah. If you have 1,000 materials in the scene, we need to have a conversation. Okay. Because your scene's probably not going to render. Let's put it that way. It's probably not going to render because that's a lot of information that's being sent to your RAM, and you're probably going to run out of memory. So I'm going to just grab the yellow guy in our list. Yoink. And you can see that it automatically picks up on all of its properties. Okay. Hit OK. Boom. Now, some of the stripes on my cone are yellow. Yeah, go ahead. Question. No, you're good. Okay, cool. You're not allowed to stretch in here. I'm joking. Totally joking. As I mentioned before, these materials are all live. So now that I have multiple polygons accessing the exact same material that's doing the yellow, check it out. If I go find my yellow material group, expand it, click on its material, maybe I change it to, I don't know, a lovely shade of pink. Or, I don't know, something different. Okay? It all updates and it's live on the spot. Okay? It's a really neat system. Okay? I love working with it. It makes it incredibly powerful. A couple other things that are important to point out, excuse me, are the visibility icons over here in our shader tree. The guys down at Luxology have been very open. They have stolen this from Photoshop. Okay, the interface it is an outright copy of the. Oh, not a copy, but it's been inspired by that Photoshop eye icon, the visibility icon. I think that eye icon has kind of become ubiquitous with visibility. So I think it's really intelligent that they've done that. So what would you imagine would happen if I deactivated the visibility icon for my red material group? For this guy. Let's check. So at the very least, it would turn off, right? Yeah, let's check it out. And I think Raphael is on to something here. Okay. So right now, the red ones are all of these stripes along my sphere, right? So if I deactivate the visibility of red, check it out. Okay. And he's right. It is automatically going back to the base material. So if I was to make the base material like yellow, okay, you can see what's going on. If I turn the red material group back on, bam, it overrides it. It overrides it, okay? So those visibility icons are a great way of very quickly activating and then deactivating the role of the material group in your scene. One of the things that I often do when I'm working on large projects is that I construct a huge system of separate material groups. I think I've shown you my 3D model of a train in here. Well, that has probably a good 50 or 60 separate material groups that I have to work with, right? Well, what if I want to turn them all off at the exact same time? What if I want to get back to just kind of that lovely gray that we're used to working with? It's a nice material to model to because it's very easy to see all the details when everything's kind of gray. Okay, I like working in this. Sometimes when you have colors in there, it's different. It's very hard to differentiate all the details. Okay, at times. So let's remember the process that the shader tree is evaluating our scene. Okay. As a reminder, the shader tree is always going to be evaluating from the bottom up, okay? So it's always going to be going this way. So right now, in the current form of my scene, it's doing the base shader first, and then it's doing that one, that one, that one, that one, that one. And eventually, it's going to work its way all the way up to the base shader. Okay. So if I could, let's say, if I wanted to get everything back to that, if I wanted to get all of these back to kind of the color of the base material, I could go in and just turn all these guys. Oops. Turn all these guys off. Okay. And now the base material is overwriting the entirety of my scene. Okay. Let's put it back to white so it doesn't look horrible. Or, there we go. All right. Rock and roll. But let me show you one other thing. Okay. And this is kind of a power user trick that I like a lot. Okay. I like a lot. I'm going to turn the rest of my material groups back on. And watch what happens now. I'm simply going to move the location of my base material to on top of all of my other material groups. Check it out. I'm going to grab this guy. I'm going to left click, and I'm going to drag it vertically within the shader tree. And watch what happens. Interesting. Interesting. Remember the basic system. Remember how and where the rendering engine is evaluating. It's always working vertically from the bottom, from the bottom going up, right? It's always going that way. So right now, what's the first thing my rendering engine is going to be evaluating? What's the first thing it's going to evaluate? I heard it. The green material group. So it is, in fact, going through and it's finding all the polygons that have been assigned to the green material and it's shading them green. Then after it does that, it's going to go find all the polygons that have been assigned to yellow, and then do that, and then blue, then the cone, and the red, and then once it reaches the top of that list, it's looking at the base shader, right? What's the role of the base shader? Or the base material, I apologize. What's the role of the base material?
Be the default color or override everything.
It's overwriting everything. All polygons are assigned to the base material, right? All polygons. So when I put it on the top of my kind of material group stack, as I have here, is shading everything according to the parameters of my base material, okay? So it's a great way for us to very quickly kind of override our shader tree and turn all of our material groups kind of off at the exact same time. Going back to my train that has 50 or 60 separate material groups, if I wanted to turn all of them off, I'd have to go click, 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 and turn each one of their visibility icons off, right? With this system, I can just simply grab my base material, drag it to the top of my list, and boom, it overrides the role of all of those material groups. Yeah?
If you turn off visibility on an item in the render tab, will it just affect the preview or the final render tab?
So the question was, if I turn off the visibility of an item, yes.
It'll affect the final render.
Absolutely. Let's experiment with that. Now, right now, I have everything on one item, okay, on my cube item, okay. However, let's put something in my mesh. Oops. Let's put something in my mesh item real fast. Shoot. Let's put a donut. I love donuts. I love donuts. Yum yum yum. Okay, so there's my donut. It's on a separate item. Let's just make it really, really simple to understand. I'll name that item donut. And while I'm here, let me just grab that donut and move it kind of in front of my little box. I'll make it smaller. There we go, something. Yep. Okay, now I'm being a perfectionist. Okay, there it is. There's my little donut. Okay. And so if I was to turn the visibility of that icon off, it also disappears. Okay. The item list, the visibility of all of your item list is absolutely going to determine what's rendered. Okay? Other questions so far? No, we all good? Really? We're all good. All right.
Can you go back over that process when you move the order of things to be rendered?
Absolutely. So what Brandon's talking about is let's go back into the shader tree. So what Brandon's talking about is how the base material is overriding everything. Okay? So here's what, in my mind, whenever I'm working with the material groups in the shader tree, I always think of them kind of like masks. Like I'm extracting the polygons that I assign to those material groups away from the base material. Okay? So everything is being influenced by the base material, and then the polygons that are in those groups are shaded separately. Okay? Since the rendering engine starts at the bottom, okay, it's basically assigning everything. And if you look very carefully in my little window over here, you can see that, let's do this. This will be a little bit more illustrative, I think. There we go. Okay. Oops. Okay. Since my computer is evaluating everything from the bottom up, everything gets assigned and shaded by the base material. Everything. Okay? So if we were to take the entire rendering process and slow it down into each sequential operation, okay? Because computers are just machines. Computers work in sequences, you know. That's really what you're doing when you're writing computer programming code, is that you're writing very complex sequences, okay? If we were to break this down into the actual sequence, everything is initially shaded and is influenced by the base material. Everything. Okay? Then it goes up one layer and it says, hold on a second, there's a number of polygons here that have been separated from the base material through this material group. I'm going to shade them according to this material group's properties. Okay? And then it does that for all the material groups in the scene. And it works vertically. Okay? Starts at the bottom, goes this way. That's the flow of information inside the shader tree. When we change the location of the shader tree, or excuse me, when we change the location of our base material to the top, to the top, the computer's still doing the exact same thing. Okay? The computer's still looking at each one of these material groups and is shading them. Okay? It's still shading, what was it? I forget what it was. It's still shading the cube green, the cylinder yellow, parts of the sphere blue. It's still doing that, okay? But then once it gets to the top of the list, when it finds the base material, it's shading everything according to the properties of our base material, okay? The base material is a global material, okay? When it's at the top, when all of our material groups are below the base material, we're in essence overriding their role, okay? It's kind of like we're temporarily turning them off, okay? So to reactivate the role of all of our material groups and get my scene back to where it was before, with the cube being green and the cylinder being yellow, what would I need to do to my shader tree right now?
Get back and you would just put it at the bottom.
Yeah, just put it at the bottom, absolutely. Just put it at the bottom. Left click, drag to the bottom. Boom, and now we're back. Other questions? Okay, let's talk for a second about the different channels in our materials, because there's a bunch of them, okay? And this is probably the most overwhelming and intimidating part about working inside of the shader tree, is understanding how the different channels within our material will eventually influence how the surface characteristics of that object kind of looks, okay? So check it out. Let me zoom out here real fast, and I'm going to do this. I'm just going to make my preview window kind of big, so it's really easy to see. So let's go into my green material group. I'm going to expand it by clicking on the dark arrow and select the material within the group. So whenever you select a material, its channels are going to come out in your Properties tab. And here they are. There's a bunch of them. Okay. I'm going to go through a couple of these. I'm not going to go through all of them, but I'm going to go through the rock stars, the ones that you really should have fluency on going forward. The easiest one is diffuse color. The diffuse color value is ultimately going to determine kind of like the basic color of that shape. Okay, it's like your car color. Okay, some people have red cars, blue cars. I have a white car. Okay, this is going to determine the color of your car. Okay, the overall color of your car. If you look closely, you can see that the diffuse color value is being calculated by 3 different parameters. These are actually RGB numbers, okay? The easiest way to interact with the diffuse color value is just to click on one of those numbers, and you'll gain entry into the Moto color picker, which is a great color picker, by the way. I love, love, love the Moto color picker. It allows us to very quickly find the color that we want, and we can even save color presets in those little swatches in the bottom part of the interface. You saw me using those swatches a little bit earlier, these guys down here. Shoot, if you're coming from the web world, I think having access to these values right in there, all the hexadecimal stuff is really, really kind of cool, okay? Because I do a lot of web work, and for the web guys, colors are defined by just letters and numbers, okay? So this is a great way of integrating the colors that are already established from like a website, for example. Very powerful.
Does there have to be like an eyedropper feature for within the same?
There's not. I wish that would be an awesome addition, a little eyedropper. That would be pretty neat. That would make my life much easier. It really would. So unfortunately, there's not. However, if you continue to look around the color picker, you can see that there's many different types of colors that we have access to, or color modes we have access to. Specifically, we're looking at the standard kind of Photoshop way, the hue saturation value, but maybe you're coming from a traditional kind of cinematography background, or if you're a studio or portrait photographer, you think in color temperatures, right? Because all light sources have a defined temperature that's going to influence the color of their lights, okay? For example, we're in fluorescence. The fluorescent lights have a much higher color temperature. I think it's somewhere around like 5600, I think, if I remember correctly, for fluorescent lights, opposed to an incandescent bulb, which has a color temperature right around 3200, I believe, okay? Which is going to make it more yellow. The higher the color temperature, the more blue that color is going to be. Okay, so portrait photographers and studio photographers are used to thinking in this world, so having access to that information is kind of rad. We also can see our traditional RGB scope, okay, which is kind of fun. I historically don't really work in this environment, but I know some people do. I'm an HSV guy for the most part. I like hue saturation value. It makes it very easy for me to quickly go in and find the colors that I want. One other thing, you also have some additional options here that will allow you to very quickly find the colors that you want. Now this is kind of neat. Under the HSV options, see this rule? Right now it says solo, but we can also do like compound color wheels. So just having access to that inside of a 3D modeling application, what? That's crazy. It's crazy. But it doesn't have an interactive color picker. Yeah, that's true. That's true. Now, I'm sure some of you are saying, okay, this is cool technology, but why in the world is this useful? Well, if you're doing motion graphics, or if you're trying to integrate consistent branding elements inside of your 3D artwork, having access to all the complementary colors from like the logo, okay, is kind of nice. All right. So it's just kind of, it's a cup holder. It is. It's a cup holder effect, but I still like it. Tints. I've used shades before. Actually, I use shades all the time. Okay. So just being able to go in and say, yeah, that's the particular one that I want. We're on our way. Okay. All right. So that's the Moto color picker. You'll love it. It's pretty easy to work with for the most part. Okay. Back to the green material. Let's put this diffuse color back to green. All right. Excellent. And we're on our way. So the diffuse color is going to determine the surface color of our object. But it's not the only one that we have, not the only channel down here that we need to draw attention to. Now I'm going to jump up to, let's see. Okay, I'm going to tell you what. I'm going to get rid of my red material group just by right-clicking on it and hitting delete. And I'm going to assign 100% of my sphere. Oops, I'm on the wrong item. Let's go to my, there we go. I'm going to assign 100% of my sphere to the blue material. That way my sphere is blue. All right. Because really what I wanted to do here was focus on a couple other material properties that are important. Okay. let's talk about the specular amount. Specular is a fancy computer graphics term. Ultimately, though, the specular amount refers to the specular highlight. Okay. Now, way back in the 80s, when this whole computer graphics industry was being generated, the fancy scientists, primarily at the University of Utah, were looking around their environment and they were looking at how light was interacting with all the different surfaces in their scene. And one of the things that they noticed really quickly that almost all objects have is a reflection of the light source in the scene, right? If you look around this environment now, I can see a reflection of the light source on everything in here, including your faces, okay? If you look at the backs of the computer screens in there, you're seeing a specular highlight. I can see a specular highlight on the printer, I can see a specular highlight on your glasses, on the windows, on that mouse, on the phones. They are everywhere. A specular highlight is nothing more than a reflection of the light source within the scene. Specifically, on my little scene, my specular highlight on my sphere is that guy right there. This is a specular highlight, okay? Now, as I mentioned, it's a reflection of the light source, okay? Now, my light source right now is just a directional light, so I'm kind of simulating the sun inside of our environment. So it makes sense that that's what our specular highlight looks like, okay? However, way back in the 80s, they were working on computers that were ridiculously slow. My cell phone has more processing power than like the space shuttle, which is like crazy to me, okay? So I could like run the space shuttle on my iPhone, which is just mind-boggling to me, okay? So they weren't working with a lot of oomph in the 80s. So what you see on that specular highlight isn't really the reflection, okay? They're faking it. They're faking it, okay? They're faking the reflection the reflection of the light source. What you're seeing there is a camera trick, okay? They didn't have enough processing power and technical sophistication both on the computer programming code and on the computer hardware to generate a true reflection, okay? So they had to fake it. Specular highlight there, still fake reflection of the scene, but it's a fake one, but it's still, it serves its purpose, okay? And it reminds the audience as to the location and the role of the light source on this surface, okay? Since it's a fake, okay, I can control it. I can control the size of my specular highlight, and I can also control its intensity. If you look very carefully, there's two different parameters down here that's going to do that for us. We have specular amount. That's going to control the brightness of our specular highlight. Right now it's at 20%. If I was to kick it to like 80%, watch what happens to this part of my sphere. Boom, what happened?
Got more dense.
Yeah, it got more dense, got a little bit sharper in the center, and it generally got brighter, okay? We increased the intensity of our reflection, okay? Now that we have a very bright specular highlight, my brain and my artistic eye is starting to say that this object is starting to become a little bit more metallic. Whenever you have a bright specular highlight with very sharp defined edges, you're having something that has what's called a quick fall off, okay? I always like to bring out a couple examples that I think kind of helps my brain process and figure out what in the world we're trying to accomplish here. Okay, so check it out. So imagine that our directional light is kind of off over here. Our directional light is here, it's shining this way, and that's the orientation of the light rays. Okay, so a whole bunch of light rays, pew 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 pew, hitting the surface of our little sphere. Okay. Now, the moment the light rays hit the surface of our sphere, it has to make a decision. Okay. Or the decision that is made is based on the quality of the surface, right? So if it's like concrete, for example, if you were to walk out to the parking lot right now, put your hand down on the concrete, is it a rough surface, smooth surface? What kind of surface is it? It's pretty rough, right? It's got a whole bunch of holes in it, pits and grooves. So what do you think is going to happen when those light rays hit all those pits and grooves? They're going to scatter. They're going to go off in different directions, right? And some of those light rays are actually going to bounce around on the interior of those little holes, right? And then eventually bounce out into the environment, okay? Metallic objects, they have a really smooth surface, okay? In your mind, imagine you're in Fort Knox, right? Somehow you've just like kicked down the door of Fort Knox and you're on, you're stealing all the gold, okay? And I like desperately want to see what's on the inside of Fort Knox. Is anyone else like incredibly curious what's going on in there? I really want to know what's on the inside. I mean, I know it's our gold reserve and everything, but what else is in there, right? Because there's like these massive conspiracy theories that like, secret artifacts like aliens are like stored in Fort Knox and stuff. I really want to know what's going on. But for the most part, it's nothing but gold bullion, big bars of gold, right? So you've busted down the door, kicked down the door to Fort Knox, and you're inside the gold vault and you've picked up a gold bar, right? Besides like almost dropping it because it weighs like 50 pounds, okay? You're holding it in your hands, and it's got a really smooth surface to it, almost perfectly smooth, okay? The gold molecules, the metal molecules are very, very tightly packed together, right? So they don't have very many, pits and grooves. It's a nearly perfect surface, okay? So what do you think is going to happen when the light bounces off of that surface? Is it going to scatter like it did with the concrete? Not as much. It's going to refract back out into the scene or reflect back out into the scene very, very quickly, okay? Quick fall off. Just adjusting our specular highlight kind of gets us closer to that result, okay? When we have really kind of soft, diffused, kind of blurry specular highlights, it's starting to remind us of skin, brushed aluminum, concrete, chalk, surfaces that have a whole lot of pits and grooves in them, where the light rays hit the surface, bounce around for a bit before they reflect or refract back out into the scene. So the specular amount is our way of kind of getting us closer to that visual surface characteristic. So specular highlight or specular amount, just the intensity of the specular highlight. If I put it back down to 10, you can see that it's very, very faint. Very, very faint now. And now we're starting to kind of resemble something that looks a little bit softer. It's not as metallic looking across the surface of my sphere. Let's put it back up to like 40%, just so it's a little bit easier for you guys to see the impact of the next channel. Now we're going to skip Fresnel. Specular color, this just changes the color of our specular highlight. That's all it does. I'm going to leave it back to white just so it's easy for you guys to see what's going on. But the next one that I want to draw focus to is actually, I think, a really important one that people overlook. It's the roughness. The roughness value is going to determine the size of our specular highlight. Now look very carefully on my screen. You can see that the size of my specular highlight is, it's kind of like right there, okay? Not too big. And specifically, it's got a really dark center, and then the edges out over here, okay, are kind of blurry. By increasing the roughness value to like 80%, let's just double it. What happened? It got big. It got really big. Okay? The roughness value is ultimately going to determine the size of your specular highlight. Okay? And this is one of those values that you work in conjunction with the specular amount. Like for example, if I wanted to create something that's metallic, I would lower the roughness value and increase the specular amount. That way I have a very bright specular highlight that has a very small, let's put it down to 10, so very small kind of pinprick, something like that. Now that's beginning to look a little bit more metallic. Okay. So the roughness value is going to determine the size and kind of like how blurry the edges of our specular highlight is going to be. I'll restore it back to its default value of 40, and then we'll move on. Okay? Now, anastrophe, just forget this value is here. Okay? Anastrophic materials are really kind of intense. I don't even think I understand how to generate anastrophic materials. It's, I think the best way to kind of illustrate what an anastrophic material is. Have you guys ever seen, every once in a while I run into like some artwork that's some metal artwork that's been, where like a grinder has been used. Have you guys ever seen that? Where if you look at it from one angle, you can see, the results of the edge grinder on the metal. Then you look at it from another angle and it's like a different color. That's an anastrophic material, okay? And they require some additional goodies and some additional settings to really make them work, okay? Historically, I think they've only really been used for metallic objects. And I don't even think I really understand the parameters. It's something that's really kind of advanced. So just forget that it's there. But Moto can do it, which is kind of fun, okay? If we keep cruising down the list, the next one that we have is reflection amount, okay? Now this is a cool one, and this is one whose effects I think just are immediately seen within our three-dimensional universe, okay? The reflection amount is basically going to turn this object into a mirror. That's all it's going to do, okay? So by increasing the reflection amount, we're kind of turning this object into chrome, okay? Let me show you what I'm talking about. At a default value of 0, that's what our sphere looks like. If I was to turn this up to like 100%, boom, pretty rad, huh? Pretty rad. Now we've created kind of like a chrome sphere within my three-dimensional universe. And it's actually doing real-time ray-traced reflections. If you look very, very carefully along the edge here, we're seeing a reflection of my purple and blue cone. Okay, pretty great. We can actually see the reflections of the shadows on the ground. Along this back edge, we're just barely, it's hard to see, but it's just barely along this back edge, we're starting to see the reflection of the cylinder, okay? So these are true global reflections from all of the different objects within our scene. Pretty cool, huh? Pretty cool. I like it. Now, for me, whenever I turn up the reflection amount, I almost always turn down the diffuse amount, because if you look carefully, see all this in here? This little line? That's the environment, okay? And, well, actually, what we're seeing there on the line is the edge of my ground plane, but in here, it's kind of blue, okay? I don't want it to be blue. Oops. If I lower this to like 10%, yeah. Now we're kind of desaturating and removing the effect of our diffuse color value over the surface of our object. So for,
Go over that one more time, please.
yeah, so whenever I turn up the reflection amount, I usually start to bring down the diffuse amount. That's just kind of an advanced thing. It just makes it look a little bit more photorealistic, okay? Reflection amount is going to turn your object into a mirror. Now, at times, we want it to go pretty far, as I've done here, but really, for the most part, we want very small amounts of reflection within the scene. In actuality, almost everything is reflective, okay? If you look around this room, almost everything is reflecting the light and the colors from the objects that are around it, including your skin, which is kind of amazing, okay? Almost everything in our world is reflective to very small degrees. So get used to going in and changing the reflection amount. I kind of, in small percentages here have a really cool effect. Like, for example, a 3% reflection amount. You can already start to see your environment at 3%. Okay? There we go. Yeah, check it out. You can already start to see the environment reflecting on the surface of my sphere at 3%. Okay? So really what this is doing is it's also driving the intensity of the reflections, okay? Much like with the specular amount. This is the intensity of the specular highlight, this guy, and the reflection amount is the intensity of the reflection across the surface of my geometry. Kind of make sense? Everyone getting it? Okay. Now I want you to look very, very closely at where the reflections are being created across the surface of my sphere. Okay? Where are they being created? Where are you seeing the reflections on my sphere?
On the surface of the sphere.
And more poignantly, across the entire surface, right? 100% of my sphere now is being reflective, okay? And you can see that by this line right here. That line, so we got blue on top and then white at the bottom. What we're reflecting here is the edge of the ground plane that's in my scene, okay? We're seeing 100% of that edge across the surface of my sphere. Just keep that in mind, because as we talk about the next one, that idea is going to become a little bit more important. I'm going to remove my reflection amount, just put it back down to 0, and my sphere goes back to its kind of matte nature. And I wanted to spend a moment talking about the role of the Fresnel effect, this Fresnel perspective, this one. This is actually a really important channel for us in the computer graphics world because, as I mentioned, almost everything in our universe has a certain amount of reflectivity associated with it. Sometimes it's very noticeable, like on a mirror, okay, or on the bumper of your car. Other times it's a little bit more difficult to see the effects of your reflectivity, like on human skin. A little bit more difficult to see, right? But the Fresnel effect is on everything in a big way. The Fresnel effect is going to handle how reflective our objects are on the edges, okay? And it's really only going to focus its energy on the edges. The Fresnel effect is a naturally occurring phenomenon. It happens out there in nature. My old boss, when I was working in San Francisco, used to call it the FedEx truck effects. Okay, so in your mind, it's a good day. It's always a good day when you get something from FedEx, right? I always love the day when you get something from FedEx. Now they even give you like a tracking number, so you can like impatiently wait. It's like, oh, I know it's coming. And what they've made it even worse now by showing like all of the stages that your package is following. It's like, oh, it's in New Jersey, okay, and then like the next day, like, oh, it's in Salt Lake City. It's almost here, and then it's in Sacramento, and then the worst for me is like they say it's on the truck, and like it's on the truck any day, any moment now. It's gonna arrive at my door. Okay, so FedEx has showed up. You're standing at your front door, and you look out at the FedEx truck that's right in front of you, right in front of you, perfectly in front of you. Okay, and what do you see on the side of the FedEx truck? The logo. The logo. You can see it perfectly. You can see the FedEx logo in all of its glory on the side of the truck just perfectly. So the guy gets out of his truck in his cool little shorts, right? And I always feel bad for the FedEx guys and gals because they're required to wear like shorts every day of the year, which is kind of weird, but whatever. So the guy comes out, he gives me my package. I'm excited about it, but being a nice person that I am, I wave to him. I wave to him as he drives down the street, right? Because I want to say thank you for my awesome thing from Amazon because I spend way too much money on Amazon. I really do. So as the FedEx truck drives down the street, I'm watching it, I'm waving goodbye, okay? And that logo on the side of the truck quickly becomes reflective, okay? As the truck travels down the street and approaches what's called the incident angle, okay? The side of the FedEx truck turns into a mirror, okay? We can no longer see the logo on the truck, okay? Now, I'm sure you guys have seen this out there in the real world. It happens all over the place, especially with shiny surfaces, right? When you're looking dead on at it, okay, when your eyes are perpendicular to the plane of the reflective surface, it's not reflective, okay? You see this with glass all the time. You're looking through a window, ain't reflective, right? But the moment that the angle changes to that piece of glass, turns into a mirror quickly, right? That's the Fresnel effect happening live in person right in front of your very own eyeballs. And we get to control its intensity here in our material properties. Okay? So check it out. If I'm just going to overdrive it. I'm going to put it up to 100%. Oh, not 1,000%. Let's do 100% and look at my sphere. Okay? It may be a little bit difficult for the folks in the back to see, but Jesse is getting a really good view of what this looks like, right? Now, Jesse, help me out. Where are we seeing the reflections?
Mostly around the edges.
Around the edges, okay? So if there's one takeaway about the Fresnel effect, it's going to determine the reflections along the edges, okay?
Might be easier to show if used on the cube instead.
Yeah, let's do it on the cube. That's a good example. Let's make our cube green, or our green cube reflective, excuse me. Okay, go into my material here. I'll drive my Fresnel effect to 100. Ta-da! Check it out. Look at where we're seeing the reflections on my cube, okay? Just on the edges, just on the areas that are facing away from the plane of my eyeball, so the plane of the camera, right in here. Okay. Now, this is something that's going to change as we change our perspective within the scene. As I rotate around, check it out. Watch this plane right here. You can see that it's kind of reflective right there. Okay. Specifically, what I'm talking about is this plane of my cube, super reflective. But as I rotate around, now this one's starting to become reflective. That's the Fresnel effect. That's the Fresnel effect in action in front of you, okay? almost everything has the Fresnel effect applied to it, just in varying percentages, okay? With highly reflective objects, it's going to be pretty high. On most things, it's going to have maybe anywhere between 0 and 10. When you start getting into really shiny objects, like for example, the Apple just came out with new phones last week, right? And they have a new model that is entirely made out of plastic. It's incredibly shiny. FYI, does anyone know what 3D modeling, rendering, and animation packages is all the advertisements are made in? That's right, the Modo. I always love that. I think that's pretty fantastic. Okay, so they're going to have a pretty high Fresnel effect on top of some other things that makes those renders look very, very glossy and very, very reflective. Okay. All right. A couple other things about reflections that I just want to show you guys. Okay. You can change your reflection color. I don't know why you would want to change your reflection color, but you can. Maybe if you want to tint your reflection somehow. Honestly, I've never done this, and I don't know why you would want to, but I guess you can. The guys down at Luxology wouldn't put it in there if it didn't have a roll. I'm just not sure what that roll is, but you can tint your reflections if you'd like.
I did it on a sphere where I striped it, and when it's showing the reflection on the bottom of the sphere where it's showing the reflection of the actual platform that it's sitting on,
Yeah.
the reflection itself is blue instead of red.
What color is your sphere?
My sphere, well, my sphere is both blue and white. The reflected part,
Yeah, is being influenced by that value. Yeah, I'm not entirely sure why you'd want to do that, but like I said, it's in there. It has a role. I've never actually changed my reflection color, but you can. Absolutely, which is where you'd want to do it. A couple other things about reflections that I just want to kind of draw focus to. You can change what is being reflective. Right now, we're reflecting everything inside of our three-dimensional scene. However, we can do just the environment. And if you look carefully what's going on in my scene, now we're no longer reflecting. Now I'm on the green material, which is why I was like, wait a minute. Let's put that back to full scene. Thank you. Now, environment only, we're no longer getting the reflection of the ground plane along the sphere, but the colors of our environment are still influencing the reflection along the edges. Okay, so that's kind of cool. Again, that's not something that I've traditionally done, but I do see its application. There is some value to that. Okay, I need to show you guys something. I'm going to increase the reflection amount of my little blue sphere here to like 10%, just so we can begin to see. Here, let's do this. Let's make it into a chrome sphere. Let's put it up to 100%. I'm also going to zero out my diffuse value to make it, there we go. Awesome. And let's do this. Let's actually put Fresnel down to 0. Yeah, okay. So now I got this really, really groovy chrome ball, and that looks really kind of lame, so let's do that. Okay. Now we're getting a little bit of edge separation, which is kind of what I was after. And because of the reflection, the reflectivity value of our sphere, of course we can see the cone, we can see the cube, and the reflection on the sphere, right? Okay, pretty cool. There is a landmine in here that people often step on that I just want to draw your attention to. Now, it is a really cool landmine, okay? It's a landmine that you want to blow up in your face from time to time, okay? It's called blurry reflections. Now, what the blurry reflections parameter is going to do here is that it's just going to take all the reflections that are being generated on that surface and it's going to blur them, okay? Why this can be a problem is it's going to kill your render time significantly, okay? We want to have blurry reflections, okay? For example, if you have some sort of brushed aluminum object in your scene, the reflections are going to be blurry. I'm looking at the back of all these monitors. The reflections on the monitors are kind of blurry. So there is a value to having this in here. I use it all the time, but I just want you to look at the results, okay? It's It's pretty cool. It's pretty cool. It's just blurring them out. The quality of the blur is increased by increasing your reflection rays. So right now the value is at 64. If I was to do like 512, the quality of that reflection is going to go up quite significantly, but as is the render time, okay? This can be a killer for your render. Let me show you what I'm talking about. Let me turn it off. There it is. Let's hit the render button. So it's going to render my scene real fast. It should render pretty quickly without blurry reflections on. Yoink, not too bad. If you look carefully in your statistics, right there, elapsed time is 5.5 seconds. Not too bad. Okay. However, now let's activate blurry reflections, and initially we'll put it at the default values of 64 rays, and let's fire off a render. Cruises through, still doing pretty good. I have a decent laptop, so it's kind of chugging through it, but you can definitely see that it's taking much longer. And the results are pretty good for the most part. I mean, we're getting something that looks pretty neat here. Okay, awesome. So that's at the default values, we were able to get an okay result, but elapsed time is now 16.8 seconds, so 3 times as slow. Okay, let's crank it. Let's give a lot of quality to my blurry reflections by increasing the reflection rays to 512. Let's see what happens. No, it won't crash Moto, but it's just going to take a while. The more rays, the higher the quality. It's thinking about it. It's going. It's doing it. It's just going to chew through it. Looks amazing. Butter smooth now. You would only really want to use this number of after. And the quality of your render is really important when you're increasing the size.
Is there a way to put in like a global value for that across all materials without having to go into each one and then
No, and you don't want it to. You want to be able to go in and control each one independently. And the reason I say you want to be able to go in and control each one independently is at times you don't want, like for example, maybe my shot is composed a little bit differently. Okay. And FYI, it took 1 minute and 10 seconds, so significantly longer. Maybe my shot is composed a little bit differently. Okay, maybe my shot is composed like this. Okay, and my donut here is a little bit reflective, as is my sphere. I want to be able to control the quality of the reflection separately because I don't want to have 512 reflection rays being blasted out on a surface that's relatively small. It doesn't need 512 to reach the same quality as my sphere. Because it's smaller and because of its shape, I can lower it down to maybe like 16 or 32 or even something a little bit smaller than that and still get the effect that I'm after. We want to be able to control these independently to get the result that we're after. I think what happens is that far too often, and I'm just as at fault in this as you guys are. We crank all the settings, and let's blast it with 1,000 rays, and then it will look perfect, right? Well, not necessarily. Okay, it's not going to look. There is a point in there where you're not going to see any additional increase in quality. Okay. Blurry reflections. It's a fun one, but it's just going to be kind of a render killer. Okay, keep that in mind. All right, clear coat's kind of cool. I like clear coat. Let's go over here to my cylinder, which is my blue guy. Let's open up its material and add a little bit of clear coat. Clear coat's another object inside of our rendering engine that's going to give us the illusion of reflections. Okay, and I'm on the wrong blue one. It's in yellow. There we go. There we go. Clear coat's kind of a fun one. Clear coat's a parameter that was added into the shader tree a couple of versions ago, and the whole role of the clear coat material property is to kind of begin to simulate like a lacquered finish on top of an object. Okay, it's an additional reflectivity property that's going to work independently from the reflective amount. Okay, it's really kind of neat. I use it all the time for plastics. Okay. because you can see that the result that we're getting is pretty cool. It's pretty neat.
Where was that?
Clear coat amount, and it's right below reflection amount. Keep cruising. All right. Clear coat amount. It's kind of a fun one. Now, right below clear coat amount is a section of our shader tree, or excuse me, it's a section of our material properties that are a whole lot of fun. Okay, the surface normal stuff, the bump amplitude, displacement distance, the smoothing angle, double-sided, rounded edge widths. These are all going to influence the shape of our object. Let me show you what I'm talking about. Okay, the bump amplitude is going to allow us to create an illusion of surface relief, so like pits and grooves across the surface of our object. Now, this is an old school camera trick. We've been doing this forever, okay? This is very similar to the specular highlight. It's not going to change the actual shape of our object. It's just going to give us the illusion of little bumps and grooves. Let me show you what I'm talking about. This bump effect has been used for a long, long time. In order for us to do this, let me see if I can find a really quick example here. I'm going to go into my sphere and just turn off its reflectivity because it's kind of taken over. Okay, cool. Turn these values to their previous settings. Yep, I got my clear coat going, which is why it's a little bit reflective in the scene. Looks pretty good. I'll tell you what, I'm just going to very simply add a procedural. Now, don't worry about why I'm doing this or how I'm doing this, okay? What I want you to really kind of focus on, here we go, is the effect of it all, okay? So this is a procedural texture. Why is my spherical projection not working? Okay. It wants to do this. Let me just go back to solid. Okay. And I'm just going to globally make this smaller. So what we get, is a whole, on the surface, is a whole series of little kind of globby black and white spots. Okay. Now, one of the cool things about working inside the shader tree is that I can take some images and change their effect. And I'm going to change this to change it to bump. This is just an illustration of the technology. Don't worry about how I'm doing this. But as you can see now, that black and white image is really kind of creating the illusion of little bumps and grooves across the surface of our object. The bump amplitude increases and decreases that effect. So as I increase this value, you can see that the peaks and valleys here are getting much larger and smaller. There we go. Now we're creating kind of the illusion of ripples across the surface of my geometry. Okay. All with a very simple texture map. Okay. We'll talk more about that later, so I know I probably just lost some of you guys, but I just wanted to show you the result of these values down here being changed. It allows us to create the illusion of relief across the surface. Pretty cool. Yeah, I like it. Let's turn up the Fresnel a bunch. Sometimes it's a little bit easier to see when it's reflective. Yep. I like it. Pretty cool. It's like a wavy, bumpy pattern across the surface of my geometry.
Is it possible to do like bloom effects within Modo?
Possible to do what?
Bloom effects with the light?
Bloom, yes, it is. The bloom stuff is a little bit difficult to kind of wrangle, but it is possible. And now that I think about it, is it something that's in 601? I think it is. Inside of the render window, you have this image processing tab. Okay, and this image processing tab is going to allow you to basically change your image after it's rendered. Okay, including we can add some bloom in here. Now this isn't something that I normally do. I don't do a lot of blooming inside of the app. Whenever I do a bloom effect, I often do it inside of After Effects, but you can do it. But I'm not a master at its properties in any way. So you can. I've seen some really great examples coming right out of what they call right out of camera, okay, right out of the render engine that has that bloom stuff on there. You can also do some really cool kind of color correction right here inside the render window before you save your image. But that's like super crazy advanced. But yes, it is possible. Okay. Actually, I believe you have to save the image to see it, but actually, no, I don't think you have to save the image. Okay. Anyways, the bump amplitude is going to change the effect of your bump maps. It's going to increase and decrease the distance that the camera is changing the relief across your surface. Same with displacement distance. The differences between the two are kind of pretty extreme. Any bump effect is purely kind of like a camera trick. It's not actually changing the surface of my geometry. However, if I was to change it from a bump effect to a displacement effect, then it physically would create a whole series of new polygons that would match the kind of the ripply surface of my object. Okay, more on that a little bit later. We're not ready to talk about how to create bump effects and displacements and work with them, but I just wanted you to see it in action. The bump and displacement effects allow us to create relief, little bumps and grooves and pits and whatnot along the surface of our geometry. Okay? Questions? Questions? Okay? The materials inside of Modo are redonkulously powerful. They really are. They allow us to create some pretty cool things quickly. In addition to changing the basic surface characteristics, we can also go into the transmissive surfaces and create transparency, luminosity. We can create the illusion of glass. We can also create the illusion of smoke and flames and stuff inside of the transmissive material properties. We'll start talking about transmissive materials, so like glass, not next week, but the week after. So we're going to come back to it a little bit later. Okay? Questions? Let's take a break. Let's take a break, okay? Yes, sir. What's up?
So I noticed on the lab last week,
Uh-huh.
the candlestick,
Uh-huh.
that was due today, right?
Candlestick was due today. Yeah. You can get it done. Just get her in.
I just,
Hello.
Can we use Moto to make video games?
Absolutely. Moto's used to make a lot of video games. That's a great looking cork board, Jesse. I like it.
Except that the PV camera.
How so?
I can't get anything but the back panel to actually do anything.
What do you mean? I see a whole bunch of pieces of geometry there.
Yeah, but I colored the rest of it and now the color's gone.
Okay, let's go over to your shader tree real fast. We might be able to explore.
I think that was one of the things I didn't like.
Go into your render item there at the top of the screen. Now expand it so we can see all the different material groups. Yeah, no, yeah, yeah. Click down. There we go. Now click on the dark arrow next to the purple render sphere. Yeah, there's all your material groups. Okay, so let's figure out why in the world you're not getting what you're getting. Okay, now go to your render tab. Hey, there it is. Yeah.
Yay.
Now the reason, go back to model, I want to show you the reason why it wasn't working. The reason you're not seeing everything selected or everything shaded right now is because of what we have selected in the item list. Go into your item list for me. Now check it out. If we were to scroll down your item list, okay, scroll down. Okay, I would imagine see whatever is selected.
I was actually do that before with all of them though.
Yeah, so how do you select all of them?
I don't remember. I think I just messed around until I got it last time.
Okay, well, I can select your first one, hold down the shift key, then select your last one. Ta-da!
I don't think it was on.
Okay. Like most things, there's a dozen different ways to skin this cat. Yeah, what's up?
When we were working with the planes for the corkboard,
Mhm.
they had one that was really kind of twisted out. And if it's coming around too much because the backside of the planes don't really have, I don't know if it's like UVs or visible polygons or something like that.
Uh-huh.
It's transparent, so
Yep.
I had to bevel it out a little bit to
Yep.
try and get it back. Is that the only way to do
No,
those?
there's two different options, and this actually brings out a really cool difference between the Moto modeling tool set. Bevel is a great one to do. Check it out though. So here is just a piece of paper, right? Transparent on the back, and that's entirely because of the surface direction, the normal. If our OpenGL viewport camera is looking at the opposite direction of the surface normal, it's just going to be invisible, okay? The moment we are in front of the surface normal, we see the surface, right? So if you wanted to get thickness on the back, beveling will work, okay? Yoink, okay? Now we have those polygons, but it doesn't fill the back, okay? If you wanted to have a polygon in the back, you need to do what's called an extrusion. Extrusion, yeah, Shift X, X as in xylophone or X-ray, will allow you to do an extrusion, and now you have that back, okay? Yes, sir.
So I just want to clarify, even if you don't go over the lab in class, it's still expected to be done?
I'm going to go over the lab in class.
Well,
No, last week, when you moved
the candlestick was hardly ever mentioned,
Oh,
so I didn't.
that's right. You guys, I'm sorry. I told you the candlestick was due today. It was not due today for this class. I apologize. And I think I even said last week, don't worry about the lab, and we'll get to it.
Oh, that is right, you did say that.
I said that. I forgot. That's my fault. That one's on me. I apologize. So don't freak out about the candlestick for you guys, okay? We'll get to it. That will be like a 10-minute lab assignment that we'll do this semester. Great.
Okay.
If you figured it out, fantastic. Okay.
It was just a simple one, right? It's all right. It was just a simple one.
Simple one. Yeah. I have a little bit of a challenge on my hands this quarter as, okay, or you can not listen to me, whatever you want.
If you're bored, you could tell me how to do shape cropping.
Say again?
If you're bored, you could show me how to do shape cropping.
Shape cropping. Help me out. I don't think I...
Describe it.
Okay. What are you trying to accomplish?
I'm trying to crop certain curved edges off of the shape.
You're trying to crop certain curved edges off of a shape.
It's like you take a piece of paper, take some scissors, and carve a piece out of it.
Yeah, that's called a Boolean. It's called a Boolean here in 3D world. Yeah.
Okay, boolean supposed to be like soup mix. Sure.
Yeah, it's a little bit advanced. We'll get to that kind of towards like week 7 or 8. So hang on to that. Okay?
All right, I'll do something else this one.
Mm-hmm.
I just looked at my grades, and it shows that I didn't submit files for the copy cup.
Okay.
But I mean, I had it done. I thought I submitted it.
Okay. So I've already gone ahead with my cork board here, and I've just did the exact same thing that I did at the beginning of class. I selected the polygons, I hit the M key, and I extracted all of those separate posters from being influenced by the base material. Okay, they're all separated out. Let me show you a great little trick. Okay, you guys will like this. It's pretty fun. When you're working with complex shader trees like I have here, often figuring out which material is influencing which part of your scene can be a little bit of a challenge. If you look at my shader tree in this particular moment, you'll see that I got about almost a dozen different materials, and I don't know off the top of my head which material group here is responsible for shading that picture, okay, this guy over here. The material group has already been established. I've just forgotten, okay? Let me show you a really cool addition to the Moto workflow. And another reason why the preview window is the coolest thing ever, because the preview window is an intelligent workflow, okay? It's a smart window. If I was to put my mouse cursor on top of my little poster here and right-click, a little ray is going to be fired out into the preview window precisely where my cursor was positioned. Whatever material group that ray intersects with is going to be shown on this little popover. Okay, so everything that's responsible for drawing the pixel, if you will, that I right-clicked on is going to show up in this list. Okay, specifically, it's also showing me right there the material group that's responsible for shading this polygon. And on my screen, it's called photo. Okay, this is more than just giving us information. Can also be used as a selection device. Check it out. If I go into that popover and click on the material group that's called photo, it's automatically going to select that material group in the shader tree. Rock and roll. Okay, makes it very, very quick, very, very quick, and very, very easy for us to go in and decode large shader trees. Okay, awesome. As a reminder, just right-click, and it'll tell you all the different factors that are responsible for shading the pixel that you right-clicked on, and you can click on any one of them, and it will automatically select that object in the shader tree. Now that I've isolated which material group is responsible for drawing this frame here, check it out. I can open it up and begin to work on it. I always like to confirm that I am working on the correct one, so let me just change the diffuse color value to something different. Yep, blue, that works. Okay, rock and roll. Now I can start working. I want to put a picture on this photograph. I don't want it to be blue. I don't want it to be a solid color or some abstract thing. I want to put a picture on there. A texture map. The process of applying a texture map to any objects inside of Modo is relatively easy, but there are a couple steps along the way that we have to follow. The first thing that we have to do in order to apply a texture to an already established material group, believe it or not, is to select the material group. In my case, photo. We're selecting a material group because we're almost kind of directing Modo to understand which group to apply the texture to. If we don't have anything selected, it's going to be applied to everything. It's just going to be outside of our shader network, and it's going to be floating just randomly inside of our shader tree. We don't want this. We want it to be placed in the folder upon import. So let me select my photo material group, and we can go on to step 2. Now this next step requires us to go to the top of the shader tree. Okay? So step 1 was to select the photo material group. Step 2 is to go to add layer. And inside of this crazy popover, these are all the different things that we can add inside of our shader tree. However, the one that we're going to be focusing on today is just an image map, a texture, a photograph, if you will. And what we want to choose is load image. Now, please be careful with this. We are loading an existing photograph. I've already saved some pictures onto my hard drive that I want to use inside these pictures here, okay, or on my posters, okay. Please do not, and I mean do not choose new image, okay? We want to choose load image, okay? If we were to choose new image, we would be creating a new image that we would like paint over in the paint tab. We want to choose load image. Single left clicking on the load image button will bring open your standard import dialog box, and here's my little machine. So let me just navigate to the directory that's storing all of my pictures. And I'm going to choose, I think this one, the fall leaves picture, okay? And I'll simply hit open. Ta-da! Yay! Mission accomplished. I know. Thank you, Hannah. Thank you. Round of applause. So I got it in. The picture's in, but am I done?
Yeah.
I guess I'm done if you like look at the world like from the left. Like if you just like lean over and look at things kind of 90 degrees wise, yeah, then I'd be done. But no, my picture's rotated incorrectly, right? I need to go in and adjust the placement of this object within inside my scene, okay? Because that picture is supposed to be in kind of landscape mode, not in portrait mode, okay? Let's look at what's happened in the shader tree because a couple new things have popped up. Okay, over inside of our shader tree, we now have our texture file. That's our image map right there. Once again, look very carefully at the icon. You can see that the guys down at Luxology have recycled that Mona Lisa icon. Okay, you saw the Mona Lisa icon when we were working with our render outputs. And from our earlier conversation, render outputs are responsible for drawing an image, right? So here we have that Mona Lisa icon kind of mapped to a sphere. So an image is on a sphere. That's the icon for a texture map. A couple things about this texture. If we were to double click on it, let's just double click on the texture. It's going to open a little image preview in its own floating window. Okay? And as you can see, I'm just using the standard viewport navigation controls here. Okay, I'm going to zoom in. Little option control, left drag mouse button. Okay. Okay. There's my image. Okay. And as you can see, it's kind of not orientated correctly on the picture that I'm trying to place it on. All right. So I can get rid of this. That's just a great preview window. In addition, if you look very carefully in your shader tree, there's one other important element that's been created. And it's called the texture locator. The texture locator, so here is our image, okay? With it selected, we're getting all of its properties down in our properties tab. And again, we're getting a whole series of vertical tabs on the right. When the other thing that's created when we import a texture into Modo is the texture locator, okay? And that's this tab right here. The texture locator is truly responsible for figuring out where on this polygon we're going to place our object, okay? If you look carefully on the texture locator, these top 3 channels are really important. We can choose the location that this texture is going to show up on our material, the rotation values, and of course the size, how big or small this is, okay? Now for our corkboard, the one that I'm working on, I need to rotate it. Let me zoom out a little bit so we can see the product of our edit. So if I go into my rotation X section inside the texture locator, let's see, I think I need to rotate it what? Not 1.5 degrees. Am I even rotating it along the right? No, I'm not. Okay, let's figure out the right axis of orientation here. Nope, not that one. Let's try Z. Oh, shoot. I forgot. This is a default that I forgot to mention, so let me take a step back. Okay. Right now, the default, whenever we're importing a texture into Modo, the default projection type is set to UV map. Now, this is a really kind of confusing and oftentimes ambiguous kind of system that we're working with here. So let me try my best to decode it in a way that's easy for us to manage. Okay. How many of you guys like going to the movies in here? Love going to the movies. I am a big movie super cinema nerd. I love it, love it, love it. Okay. I love that communal experience that we have going to the movies, right? Sitting with a couple hundred of your closest friends and sharing an experience is kind of unique. I think it's cool, right? The projection type is kind of similar to the digital cinema projector that's in the back of your movie theater, right? If you think about it, what is that projector doing? It's blasting an image onto a big screen, right? That's all it's doing. It's taking the celluloid, the film that's rolling through the projector, is shining a light through that film, and as the light leaves the film, it's then projected out into the screen, right? Kind of basically what's happening. Well, we're kind of doing the exact same thing digitally here. Our texture locator is kind of like that projector, that little cinema projector in the back of the movie theater, and it's blasting an image onto the surface of a polygon, not onto that big screen that you see in the cinema, okay? So its type, this is kind of its method of projection in this window. Right now, its method of projection is called the UV map. We'll talk about that much later. 424, we discussed the role of the UV map in detail. You leave 424 as like UV mapping ninjas, okay? But we're going to change it, and we need to change it. This is the default. If you don't have a UV map, and you don't because you haven't made one, okay, you need to change this, okay? The default's always going to be UV map. For like 90% of this course, we need to change that projection type. Now, if you look at the list, there's a whole bunch of different options here, and just ignore all the ones that are below UV map, but ignore front projection. So we got solid, planar, cylindrical, spherical, and cubic. We need to kind of look at the shape that we're trying to project this image onto and choose one of these projection types that matches the shape. Okay, now what shape is my poster? Yeah, it's a square. It's a cube, right? So we can either use solid. Okay, solid's kind of a good one. If you don't know which one to pick solid. Okay, that's going to give you a result either way. Planar is another good one. Mine's actually a plane. It's just a single two-dimensional plane. Cubic would be something that you'd want to use if your object has 6 sides. Okay, but for me, I'm going to use planar. Okay, and for your posters, if you kind of follow the directions that I issued last week for your posters, and if you've been following along with the live streams and the time-lapse videos, I made planes. I made two-dimensional cubes, okay, that don't have any depth. So I'm going to choose planar. My object's not a cylinder and it's not a sphere, so I'm not going to choose these two at the moment. But I am going to choose plane. Now we need to choose at which orientation our little digital cinema projector is blasting this image onto our polygon. This takes a little bit of exploration. So depending on the orientation of your object within your scene, you'll need to change the axis. I think mine needs to be going blasted down the z-axis, so I think I'm pretty good. Let me zoom out real fast. Let's see what we get. Haha! Okay, look at this. Our image has changed a little bit. Okay? We have the right, almost the right aspect ratio now. It's kind of in landscape, but we have 7, 8 stamps of the exact same thing. I don't want 8 stamps of the exact same thing. Okay? Texture files or texture maps are always going to do what's called tiling. It's going to repeat that image infinitely along both the x and the y-axis and the z-axis. Okay? I don't want that. I only want to see one picture, right? Uno. So I need to change 2 important things. Okay? It's called the horizontal and vertical wrap. And you can find this parameter, or excuse me, the horizontal and vertical repeat. I apologize. You can also find this parameter below your projection type. And you can see that the defaults are repeat. If we turn it to reset, we're basically turning off that tiling function, and we're only getting, well, we are getting 1, it's just not in the center of this polygon yet. Okay? We need to put it in the center of the polygon. With the horizontal and vertical repeat set to reset, we need to figure out where in the world our little guy is. Okay? Now, yep, there it is. Okay. I mentioned earlier that our texture locator is responsible for placing this image on top of our polygon. Now, I have my material group selected, and specifically, I have my image map selected inside my shader tree. So in item mode now, I can cruise around, and sometimes it's difficult to find, but there it is. That little white outline is my texture, and that in its current location represents where my little projector is blasting it towards. Okay, I need to move it, so I'm in item mode, and I can just hit the move tool. Check it out. Oops, I'm moving my cube. Hold on a sec. Let's do this. Here's one other thing that you can do, just to kind of make it easy to select your texture locator. See this little plus sign? If you click on that plus sign, it'll expand your texture and fall leaves. That's the actual texture locator that's responsible for placing this image within the scene. Okay. Now, if I hit the move tool, yeah, there it is. Now I've selected what I want to select, and let's get it where we need it to go. Haha, there it is. Ta-da! Okay, we're getting there. We're getting there. It's a little small. Okay. So here's what I'm going to do. Here's the shortcut. I always try to do this first. Let me, oops, excuse me. Miss not having a mouse some days. There we go. Let me drop my move tool, excuse me. Drop my move tool. And go back into item mode here real fast. And I'm simply going to scale it up. You can even stretch it out if you want. You can rotate it. You can use all the standard transform tools to put this texture where you want it to go on top of your guy. Okay, which is really kind of neat. Something maybe like that. Ta-da! And that's looking pretty good. Okay. Questions on this process? We're going to do it a couple more times. So if you didn't get it the first time, we're going to do it like 8 more times. Let's do it again. It's a pretty easy process. What's the first step? Do you guys remember what the first step was? I want to place some images on my little post-it notes up here. Okay. What was the first step? We got to select the material group. Now, is there an easy way to have the computer automatically select the material group for us? Yeah, we can right-click on the actual object, and this is something that's only available to us in the preview window. So I can right-click on the object in my preview window. It'll give me this little pop-over, and there's the material group. I can click on it, and it'll automatically select it for me in the shader tree. With the shader tree, or with that material group selected in the shader tree, I can go Add Layer, Image Map, Load Image, and I'm just going to grab Post-it Note 1 and hit Open. Okay, Brad was here. Pretty cool, huh? Now, we have to change a couple things inside the texture locator. Specifically, what are we going to change? Projection type, right? What do we want to have this on? Planar. Planar's a good one to have. I'm a big fan of planar. This is a flat, plane shape, so planar is a good one. However, once we change that, we can see that the texture is starting to repeat itself across the surface of my little Post-it note, right? So what do I need to change now? The repeat, the horizontal and vertical repeat. And which option am I going to put it to? Reset on both. And now we only get one. Here's kind of another cool little trick. If you don't want to mess around with the texture locator and you just want to get the placement of your texture kind of close to the object, there's this auto size down here. This is a good one. I always try auto size first just to see how far it gets me. Sometimes I get lucky and it'll just do it perfectly right on the first try. Let's hit auto size. Boom. Yeah, it's close. It's close. I'm happy with that for the time being. Okay? Let's do it one more time. I want to put something on that back guy. So I want to right click on it, Post-it note 3, add layer, image map, load image. Here's the image that I'm going to put on there. Hit open. There we go. I need to change the projection type from UV map to planar, and then turn off the horizontal repeat as well as the vertical repeat. And I'll simply hit auto size just to see, yeah, it got me close. It's not perfect. I could go in and let's rotate it around a little bit. That's definitely not right. So let's find the axes. It's probably going to be Z. Yeah. I'm just rotating it so it kind of matches the correct orientation. You can see it down here in OpenGL, what it's going to look like. Okay. All right. How about this one? Let's do that one real fast. Right click on it, Post-it note material 2, add layer, image map, load that image in. Let's do, I don't know. Yeah, let's do this fall leaves. Sure, why not? Boom. Okay. Now, what inside the texture locator am I going to change for that image? Walk me through the steps. A couple things we need to change just right off the bat. Projection type is going to go to what? Planar, because it's a flat surface. What am I going to do? The horizontal and vertical repeat. Reset it. Let's take a look-see at it, and I'm just going to do auto size. Sometimes that just gets me close, and now I'm pretty close, and I'm on my way. Okay. Pretty cool, huh? That's how we're going to be able to go in and very quickly add images to all the different parts of our corkboard.
Will it warp the image to the bends and the polygons on the plane?
A little bit. A little bit. A little bit. In order to get, if you had a really bent object, and the only way for it to get a perfect kind of deformation of the texture across the surface of the mesh is to have a UV map. So we're just going to use the simple projections for the first couple weeks, and then we'll advance into that UV mapping stage, because making UV maps is pretty difficult, and we're not quite ready for it yet. I'm not going to sink you guys in the first time out. Okay, other questions?
Sorry, I was lost. First, how do you add the picture to the paper?
Yeah, let's do it one more time. I have a newspaper here sitting in the center of my corkboard. Let's check it out real fast. Okay. So I'm going to right-click on. Right-click on the object. Here's the newspaper. I already have the material or the image map in there, so I'm just going to delete it. Okay. So help out Darren here. What's the steps? What are we going to do to get an image onto that material group? Add layer at the top of the shader tree. Right there. Add layer.
You have to be selected on the paper first, right?
Yeah, you want to make sure that your paper is inside of a material group. Okay? And then you have that material group selected in the shader tree, as I do here. See that right there? Okay. Then we can do add layer, image map, right? Load image. Here's my newspaper. There it is. Now this is a really great example. This newspaper is just completely wacko right now. Okay, it's not orientated the right way. So what do I need to do to my texture to get it to work correctly? Where am I going to go initially? Texture locator, right. Texture locator is responsible for the placement of my image within my three-dimensional scene. Now what? Yeah, the projection type is going to be switched from UV map to planar. What's next? Yep, horizontal and vertical repeat are going to be set to reset. And let's just see what we have here. Yeah, let's just do auto size. Auto size kind of does a really great job of figuring out where the polygon is and what size it is, and it automatically moves and rotates that image map to that polygon. Okay? Pretty neat, huh? Yeah, no problem. Let me show you one other thing that's kind of cool. We can use image maps in a number of different capacities. We've been using image maps up until now just to very simply and very quickly create some, put a texture on our polygons, right? But we can also change the effect that these image maps are having on our polygons. If you look very carefully at my newspaper here, you can see that the newspaper has kind of these little torn edges. Now, I could, if I wanted to, go in with my modeling tools and model a newspaper that perfectly matches all these little torn edges, because I don't want, I only want to see the newspaper on the interior of my texture. I don't want to see my polygons out over here, right? But that's a tremendous amount of work. Tremendous amount of work. So I want to use the transparency channel of this image to affect the transparency of the polygon. Okay, it's really kind of cool. Check this out. We can use image maps in a number of really exciting ways. I want to change the effect of this image map. Check it out. I'm going to zoom into my shader tree, and you can see that our shader tree is really broken out into two columns. We have this section where we've been working with, or where we've been working in up until now, and then we have this column over here, and it's called the effect column. By default, all of our image maps are going to be applied to the diffuse color value, so it's going to determine the color of our car. Okay? But I want to change the effect. We can change the effect of any of our image maps very easily by right-clicking on the effect. So I want to right-click on diffuse color. And here's a crazy long list. And let's see, I got to remember where they placed it. They recently kind of shuffled some things around. I think it's in basic channels. No, it is not in basic channels. Let's see. Special effects. Here we go. Under special effects, check it out. We get RGBA, which is really kind of neat. The RGBA effect is going to take the red, green, blue channels of any image and the alpha channel, which is responsible for transparency, and using that to drive the transparency of our polygons. Let's just apply that effect. You can zoom out for a second, and you can see what's happened. Okay? Where the polygon was purple outside of my newspaper has been now made transparent. Pretty cool, huh? So image maps play a much larger role inside of our rendering system than just making, instead of just bringing making it a picture. Okay, we can use these pictures to drive a number of really fantastic channels and advanced material effects, some of which we're going to be exploring over the next couple of weeks. Okay, that's just kind of a teaser of what's coming up. All right, questions on what we've talked about today? No? Everyone kind of good? Understand the basics of it? I think once you get in and get your hands dirty and start applying these material masks and these groups and importing the textures, you're going to find that there is a certain kind of repetitiveness that you'll become accustomed to. Okay? I want to spend some time talking real quick about our lab assignment today. Our lab assignment is going to be the let's go back over to renderography. The lab assignment is going to be the lighthouse. The lighthouse is going to be really fun. It's just our way of getting our hands dirty with applying materials. Okay, so for our lighthouse, a couple different things. You need to have materials and textures for all elements within the scene. Okay, everything is going to have a material or a texture applied to it. Everything. Okay, you need to create two renders. Two renders of the scene from alternating angles, okay? And we'll talk about that again here in a second. So very vastly different alternating angles that kind of like showcases the totality of the scene. Global illumination needs to be turned on. I've showed you how to do that as a refresher. where do we go in our shader tree to activate global illumination? Render, yeah, you got it. So if you go into the render item, the purple sphere, it's one of the vertical tabs on the right-hand side. Global illumination, and just turn it on. Boop. That's all you got to do for this one, okay? And then the final render frame size. Let's talk about that one real fast. Up until now, we've been rendering everything at 720 by 480. Please note that I am in the render item, okay? I've clicked on the purple sphere that says render, and down in the properties tab, the first, we have a couple vertical tabs here. One's called frame, okay? And here it is, frame width and height. Those are going to drive and determine the size of our render, okay? Starting today, everything, and I mean everything that we produce in this class is going to generate a render that's 1280 by 720, okay? We're increasing the resolution of all of our renders so that we get some high quality pieces of artwork that you can use in your portfolio and you can share online. So 1280 by 720 is a good set of numbers to start with, okay? So let's just do 1280 for the width, height, 720. You can leave the DPI and the pixel aspect ratio at 1. And now, as you can see, we're going to create a rectangular image. And if you know these numbers, and if you have any experience inside the television and film world, these numbers may seem a little familiar because they are. This is really fundamentally the frame width and height for 720p high definition television. Okay? So that's the kind of images that we're creating. We're creating HD television images here. Okay, so now when we render, it's going to be a much higher quality image. It's almost twice the size of the images that we've been creating so far. Okay? As always, at the conclusion of all your renders, please make sure you're hitting the gigantic save button down here. Don't forget to save your image. Please don't forget to save your image. And what format are we going to be saving our images in? JPEG. So save image, and then JPEG right there. Okay? Everything that we produce in this class is going to generate a JPEG, a render, and the Luxology project file. So please make sure that you're submitting both of those to the Dropbox when you're done with this assignment. Let's look real quickly at the actual model file itself. You can get access to the model file right there inside of your the Resources tab. Left-clicking on it will download it. Okay, here's the zipped archive. Don't forget to unzip it. Let me just open this up in 601. It's a pretty cool little scene. I think you're really going to dig it. It's a fun one to work on. So your job over the next, we had about 30 minutes left in class. You may be able to knock this out real quick. Your job is to go through and apply material groups to everything in the scene and use and create some materials for them. They can be just simple colors. I'm not looking for anything that's photoreal. So don't worry about going in and using trying to make it look like grass and rocks and stuff. Just think colors, okay? I just want you to get into the habit of selecting things, hitting the M key, and changing some of those basic material properties to create the illusion that we're after, okay? Please note, in this scene, a number of these assets are broken out into their own item. So for example, if you wanted to make the water blue, just make sure you're on that item before you try to hit the M key. That'll save you some frustration, okay? Not everything's on one item as it was in the scene that I was previously working on. Okay, questions on what we're going to be accomplishing this week. So the lab, lighthouse, and I need 2 alternating renders of the lighthouse, okay? If you give me a render that looks like this, okay, that's cool. That's good. I love that. But if you give me another render that looks like that, fail. Okay. Alternating renders, okay? I really want to see 2 different perspectives within inside this scene. We have this wonderful little playground in here for you to take photographs of, okay? So alternating renders. Be creative. Explore the scene and try to find something, some composition here that's compelling. Something that may make a really cool photograph, okay? Also, if you turn in a render that looks like this, fail, okay? This is not a picture of the lighthouse. This is the picture of the entire scene. So what people have done in the past, they get in a hurry, they're late, they hit the A key in their preview window, and they hit the render button. The A key is going to auto-fit the entire scene into your window. Okay, so fail. Don't do that. Don't do that. Get in there close. It's a really cool little scene, and I just went in too far. This is a really cool little scene for you to play with. Have fun with it. Okay, have fun with it. Be creative. This is an art class. I want you guys to flex your creativity and to start exploring this art form in an artistic manner.
The candlestick from last week, is that due, or are we going to skip that?
Don't worry about that one. Maybe we'll do that at the beginning of class next week. Yeah, we'll come back to the candlestick. So don't stress about the candlestick. That really is like a 20-minute lab assignment that you can bang out in real quickly. Okay. So don't freak out about that one. Questions? Yes. Okay, one final thing before I jump in and start helping individuals. Let's just refresh our memories as to what we're doing for the homework this week. We're doing the corkboard texture, okay? A couple specifics that I want to make sure everyone's aware of, all right? You should have the model done by now. It should be done. It was due today, so you should have all the modeling of it done, okay? This is all the modeling. Now, we're going to extend it. Separate materials for all items in the scene. Texture maps for all postcards and flyers, so there should not be a blank poster or whatever on your corkboard. Everything should have a texture map or an image map applied to it. As we just discussed, please make sure that global illumination is turned on, as well as recognize the new render size, 720 by 4 or 720. It's end of the day, my brain's turning into mush. 1280 by 720. I apologize, and we're saving it out as a JPEG. I've given you some really great examples of some successful student projects downstairs. So if you want to look at what some of the other folks have been doing, I say do it. I really don't care as to what's on your corkboard. Please make sure it's rated E for everyone. Okay, so no adult content on the posters in your project. Okay. And I wouldn't say that if people hadn't done it in the past. So please make sure your content's rated E for everyone. As with all the projects that I do in the first month, there's a time-lapse video where you can see me actually applying all the textures to the posters. It's kind of a regurgitation of what you just saw me do. So if you want a good refresher, the time-lapse is down there. This is due by the beginning of class next week. It's worth 50 points. Please make sure you're turning in both your Luxology project file and your render at the conclusion of this project. Questions? All right, one final administrative things before I kind of let you guys start working on your lab if you haven't already. I posted grades for your coffee cup and for your unit primitives. If you did not get a grade, or if you think if your grade was awarded in error, please come find me. It could be an administrative bug or human error on my part. As much as I would like to think I'm a robot, I'm really not. Mistakes are made. I want to make sure those mistakes are kind of rectified before we go any further. Okay? Questions, questions, questions. Everyone good? All right, we got about 25 minutes left in class. Let's get to work.
My coffee cup.
Coffee cup. Let's do it. All right. I stopped the stream, turned it off, so we can do this.
If you want to just check the dates or...
Yeah, I'm more concerned. It's not so much, I mean, I know you did it.
You know, I might have just uploaded the previous project and thought I uploaded this at the same time, or
Yeah.
some such.
Let's explore this.
It says I submitted 0 files, and I thought I had.
Okay.
I might have just...
Okay. Let's see what's going on. Dropbox. This is a